Okay. Yeah. Good evening, dear students. Yeah, welcome to the session. Yesterday, we are completed the distributed winding in total. We have seen the difference between distributed winding and concentrated winding. The main difference between distributed and concentrated winding is if all the coils related to R phase, they kept only in one slot, say, that is said to be distributed winding. Like R1, R2, R3, if you keep all the coils kept in one slot, concentrated. But if you distribute at least minimum 2 slots or more than 2 slots, okay, fine. So R1, R2, R3, if they are distributed among the at least minimum 2 or maximum, there is no limit, 3, 4, 5, 6, that is distributed winding. But when winding is distributed, say, the resultant voltage will be vector sum. Why? Because the coils are placed in different slots, means there will be space displacement, and it is also causes space displacement. Space displacement is there. Phase difference will comes into picture. It will be the vector sum. Okay, it's a vector sum. But whereas for concentrated winding, it will be arithmetic sum, because all coils are kept in only one slot, means there is no phase difference. The induced EMF in all the slots will be in same phase. Right? Yeah. Now, and we have seen the phase spread for n phase machine 180 by n. Phase spread for single phase machine 180 degrees, 2 phase 90, and 3 phase it is 60 degrees. Of course, for 3 phase 120 degrees phase spread also very rarely used to eliminate the triplen harmonics in the phase voltages. Triplen harmonics in the phase voltages, right? But anyhow, 60 degrees phase spread also, triplen harmonics will be eliminated in the line voltages. Though they generate in the phases, they will be eliminated in the line voltages. Okay. So unless otherwise mentioned, alternates will be always it is 60 degrees phase spread. 3 phase machine means you have to take 60 degrees phase spread only. If it is given in the examination, then you will think about. Otherwise, simply you leave it. Okay, just to have an idea. Yeah. And we have derived, so we have seen the distribution factor. Distribution factor is equal to sin m gamma by 2 divided by m sin gamma by 2. Okay. And also we have seen very important discussion, that is relations between various phases. What is the relation between single phase, 2 phase, 2 phase, 3 phase for various alternators? And it is also observed that for 3 phase, kVA rating is more. kVA rating power output will be more for 3 phase. That's the reason 3 phase generators are famous. In generating stations, we will use 3 phase alternators only. Single phase alternators are very rare. Single phase alternators are used only for domestic applications. Fine? Yeah. Now, also we completed some problems. Fine. Now let us see some more problems. I just want to do one or another problem. See. And after that we will go to the next another topic. Okay. Yeah. Take down this problem. Problem is calculate RMS value of problem. Calculate RMS value of induced EMF. Induced EMF of 10 pole 3 phase 50 Hz alternator with slots per pole per phase. Slots per pole per phase. With 2 slots per pole per phase. With the 2 slots per pole per phase. Per pole per phase. and 4 conductors per slot. 4 conductors per slot with a double layer winding. Okay. Coil span is 150 degrees. Flux per pole is 0.12 Webers. 0.12 Webers. Okay. Yes. So induced EMF. What is the induced EMF? Okay. Calculate the RMS value of induced EMF of 10-pole 3-phase alternator with 2 slots per pole per phase and 4 conductors per slot. With the double layer winding, coil span is 150 degrees. Flux per pole is 0.12 Webers. Okay. The solution is, data given is what? A 10-pole 3-phase. A 10-pole 3-phase 50H alternator. Then slots per pole per phase is 3, na? Slots per pole per phase is 3. Is equal to 3. And that is SPP. Slots per pole per phase is, what is that? SPP. M is equal to 3. Okay. Then what is the total number of slots? From this we can calculate total number of slots. Total number of slots is equal to slots per pole per phase 3, na? Yes. Therefore 3 into slots per pole 10 per phase 3. Slots per pole per phase 3 means I am multiplying poles and slots. Phases. How much it is? 90. Slots per pole per phase is 90. No, sorry. Slots per pole per phase it is 2, na? No, 2 is given. Slots per pole per phase is given 2. This is 3, not 3. Slots per pole per phase 2 into slots per pole 10 poles 3 phase is equal to how much? It will be 60 degrees. 60. Total number of slots are 60. S is equal to 60. Okay, that is yes. Now calculate slot angle. And first of all, calculate total number of conductors. How many conductors? It is given double layer winding. And 4 conductors per slot. Therefore, it is a double layer winding. 4 conductors per slot. Like how many slots are there? Up to 60 slots. Up to 60 slots are there. 60 slots. And it's a double layer. How many conductors? 4 conductors per slot. 4 conductors means this is 2 and 2. Together is said to be 4 conductors. 2 and 2. Okay. These are the layers, na? These are the layers. Coil sides are layers. Two layers are there. This is also one coil side. This is also another coil side. 4 coil sides are there. Layer is nothing but coil sides. But each layer, 2 conductors are there. Totally how many conductors? 4 conductors. 4 conductors here and 4 conductors here. Therefore, what is the total number of turns? Total number of conductors. Total number of conductors is equal to, see from this, total number of conductors. Total number of conductors is equal to total number of conductors is equal to 60 slots are there, but in each slot 4. 60 into 4. Total number of conductors. And what is total number of turns? Total number of turns is equal to 60 into 4 by 2. 60 into 4 by 2. Total number of, okay, yes. Total number of slots per pole per phase, how much it is given? Conductor per slot 4. How many slots total? 60 slots, na? Yes. 60. Okay. Then what is total number of conductors? 60 into 40. Correct. Then total number of turns is equal to, that is equal to 60 into 4 by 2. And what is the total number of turns per phase? Turns per phase. TPH. Turns per phase is equal to 60 into 4 by 2 into 3. 2 into 3. How much it is? Turns per phase. Turns per phase is equal to 40. Turns per phase is equal to how much? It will be 40. Now, okay. Then see, calculate KP value. Gamma is equal to, first calculate GD. Gamma is equal to P into 180 by S. P into 180 by S. P is equal to how much? P is equal to 4. P is equal to 4 poles, na? Yes, 4. Oh, sorry, 10 poles. 10 poles, na? 10 poles. P into 10 into 180 divided by how many slots in total? The total slots are 60. 60. So therefore, what is this? Is equal to 30 degrees. 30. And already we have got slots per pole per phase. M is equal to SPP. M is equal to 2. Therefore, calculate KD. KD is equal to sin M gamma by 2 divided by M sin gamma by 2. Sin M gamma by 2 divided by M sin gamma by 2. And that is equal to sin M is 2 into gamma 30 by 2 divided by M. 2 into sin gamma by 2. 30 by 2. So that value KD is equal to how much? It becomes 0.966. KD 0.966. And coil span is given. Coil span beta is equal to 150 degrees. Beta 150. Then what is alpha? Alpha is 30. Therefore, Kp is equal to cos alpha by 2. That is cos 30 by 2. So cos 15. Cos 15 is equal to 0.966. Is also 0.966. Then, yeah. E is equal to 4.44 Kp Kd phi f TPH. So that is equal to 4.44 Kp. Kp how much? 0.966. Kd also 0.966. Phi flux per pole is how much? Flux per pole it is 0.12. 0.12. Frequency 50. Turns per phase how many? Turns per phase is 40. Then what is your answer? Answer is 994.37 volts. Okay. Right. Yeah. Now I will ask one question for you, dear students. I will ask one question for you. You have taken this now? Yes. For example, see, for example, if I give single layer winding, say, in the same question, if I give instead of double layer winding, single layer winding, I will give. What is your answer? Tell me. Single layer winding. Single layer winding. What is your answer? You are expecting. Instead of double layer winding, if I give single layer, all other data same. All other data same. What is your answer? Tell me in the chat box. The remaining data means 10 pole 3 phase alternator with 2 slots per pole per phase, it is same, and 4 conductor per slot, same, with a single layer winding. Coil span is also 150. Flux per pole is 0.12. What is your answer? Tell me. EMF is going to be reduces or same or increases, double or what is your answer? Yes, what is your answer? Same, reduce, same, double, same. This is a 4 conductor is not possible in single layer winding. 4 conductors is not possible. It is possible. Okay. See. If I give single layer winding, that is itself going to be one question. Let me see this question. See, all the data same. All the data same. You can treat this is another problem. Another problem. It's another problem. With same data as above. But only thing is, poles are different. A 10 pole question is same. Once again I will write. A 10 pole, 3 phase, 50 Hz alternator. 50 Hz alternator. Okay. With the slots per pole per phase. 2 slots per pole per phase. 2 slots per pole per phase. And 4 conductors per slot. 4 conductors per slot. 4 conductors per slot. With the single layer winding. This is only different. Single layer winding. Single layer winding. Right? Single layer winding. Coil span same. Coil span same. Coil span beta 150 degrees only. And flux per pole. Flux per pole also. Flux per pole. Phi is equal to how much? 0.12 Webers. Then EMF. Then EPH is equal to how much? How much? Yeah. See here. Same question. And the question is same as above. Question is same as above. Only single layer winding. If it is a single layer winding, that's all. Instead of double layer, if it is a single layer winding. If it is a single layer winding. Single layer winding. Okay. Single layer winding. Then answer. See. Total slots are same. Total number of slots same. Total slots are. Total number of slots same only. How much? That is 2 slots per pole per phase 3. How much it is? 60 only. 60, correct. Total slots, number of slots are 60. Yes. And 4 conductor per slot. Single layer winding, 4 conductors per slot. Single layer winding, 4 conductors per slot. Important thing is, this is the important thing. 4 conductors per slot and it will be single layer winding. These 2 things are important to decide the number of turns. In this, how he is giving 4 conductor slots are same. Total number of slots are same. How many? Yeah, up to 60 slots. Up to 60 slots, na? Yes. But it is a single layer winding. Single layer means only one layer. Single layer, one coil side. How many conductors here? 4 conductors, he is saying 4 conductors. 4 conductors. Okay, 4 conductors. 4 conductors. It means this is alternator. Alternator. In this, we are keeping, this is a coil. This is a coil. This coil is having 1, 2, 3, 4. This is a coil. It is a 4-turn coil, correct? The 4-turn coil. 4-turn coil. So how many conductors per coil side? This coil side. This is a coil side, 4 conductors. Coil side, 4 conductors. In this coil side, 4 conductors. In this coil side also 4 conductors. This is also coil side, 4 conductors. 4 conductors. It is a 4-turn coil. 4-turn coil. This is one layer. Coil side is nothing but what? Layer. Coil side is called what? Layer. That is important point you need to remember. 4 conductors. That is also 4 conductors. Okay? Yeah. A coil can have any number of turns. Dear students, a coil can have any number of turns. Earlier example, if you see, yeah, see here, in this example, 4 conductor per slot means, see here, in this example, 4 conductors now up to, just let me write here earlier, up to 60 slots, okay? But this is like this. It is said to be, there are 2 layers are there. 2 layers. One is red color. Red color can be kept 1 and 2. Only 2. This is one coil. And another coil, say, another coil also having another. This is another coil. Now, how many coils are there? 2 is there. 2 coils are there. 2 layers. Coil side is called what? Layer. Coil side is nothing but layer. Coil side is nothing but layer. So how many conductors per slot? 2 conductors in one layer, 2 conductors in another layer. 2 conductors. Coil side is nothing but layer. So therefore, this is also 4 conductors. Next question, what I have given, single layer winding, but it will be 4 conductors again. 4 conductor means 4 conductor this side, 4 conductor this side. That is it. 4-turn coil. 4-turn coil. Earlier one 4-turn coil. But what is this? These are the 2-turn coils. These are only, the difference is 2-turn coils. These are the 2-turn coils. 2-turn coils. But next example, whatever I have given, 4-turn coil. 4-turn coil. Okay, this is a 4-turn coil. 4-turn coil. Are you getting? This is a 4-turn coil. So finally, what will happen? 4 conductors here, 4 conductors here. Therefore, what is the total number of conductors? Total number of conductors is equal to 60 into 4. 60 into 4. Then what is the total number of turns? Total number of turns is equal to 60 into 4 by 2. 4 by 2. Then total turns per phase. This is total number of turns. Turns per phase. TPH is equal to how much? 60 into 4 divided by 2 into 3. That is equal to 40. 40. Total number of turns are same. KP, KD, rest of the things are same. KP, all other. KP, KD, other things are same. KP, KD are same. I don't want to calculate. Therefore, what is E? EPH also same. EPH is equal to how much? EPH is equal to, earlier example, how much we have got? It is also same. 994.37 volts. Okay. Hey, don't think single layer winding, double layer winding. Earlier single layer winding means don't think half. You have to see this how many number of conductor per slot. Okay. The difference is coil. It's not only single layer, double layer, but how many tons are there in each coil is a matter. How many tons are there? Okay. The first one is 4-turn coil. Sorry, first one is two turn coils. How many? Two coils are there. Two coils are kept in a pair of slots. Right? Okay. Next question. I'm not going to use total question. A three-phase, 600 RPM, 10 pole alternator, 10 pole alternator. Okay. Slots, total number of slots. Alternator has 144 slots. 144 slots. Double layer winding containing two layer winding. Containing two layer winding. Two layer winding. With 5 conductors per coil side. With 5 conductors per coil side. 5 conductors per coil side in each slot. In each slot. Okay? Yes. Now, what is the number of tons? Total number of tons. I don't want to do the entire problem. Only students, they are just confusing tons calculations. Tons calculation. Rest of the things are simply formula based. Na? Yes. KP, KD, we know already. We have done KP, KD problems. Then what is the number of tons per phase? Then the tons per phase, TPH, is equal to how much? Tons per phase. I want to focus on tons per phase. Tons per phase. See, tons per phase. One 144 slots, double layer winding. Total number of slots are 144 slots. S is equal to 144 slots. No? 5 conductor per coil side. The double layer winding. Double layer winding. Double layer winding. 5 conductor per coil side. 5 conductor per coil side. These two things are important. Double layer winding, 5 conductor per coil side. So 144 slots are there. 144 slots are there. Slot 1, slot 2, like 144 slots are there. Up to 144 slots. It is a double layer winding. Double layer winding. Okay, double layer winding. Double layer winding. How many conductor per coil side? 5 conductors per coil side. 5 conductors means it's a 5 conductors per coil side. 1, 2, 3. How many conductors? 5 conductors. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 conductors per coil side. Let me write a bigger one. The board is very small. Okay, 5 conductors per coil side. Up to 144. This is the one coil. This is another coil side. No? One coil side, another coil side. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This is coil sides. These are called what? Coil sides or layers. These are said to be coil sides or layers. Layer means coil side. Layer or coil side. But how many conductor per coil side? this is 5 conductors per coil side, na? Yes, 5 conductors per coil side. 5 conductors means how many total number of conductors? Here, 10 conductors. Here it is, how many? 10 conductors here. 10 conductors. Here also, 10 conductors. Therefore, what is the total number of conductors? Yeah. I hope you understood now. This is diagram. If I take double layer, no? Every time I'm drawing because the students are asking these doubts only. You practice, you will also make it doubt. How it is? See, red color coil I will take. Red color coil having how many? 5 conductors. 5 turns it is. 5 turn coil. 5 turn coil. Okay, this one. This one. And another one, black one is also 5 turn coil. 1, 2, 3, 4, 5. Right? So in each type, in each, it is how many coils? This is also coil side or layer. Layer or coil sides. Layers or coil sides. Coil sides. So these are said to be 5 turn coils. I can say it is 5 turn coils. 5 turn coils. 5 turn means on each slot 5 conductors. 5 conductors that side, 5 conductors this side. Yeah. After this, I will. You are raising a doubt. I will clarify once again. Let me complete this question. 10 conductor per slot means what is the total number of conductors? Total number of conductors is equal to 144 into 10. Then total number of turns. Total number of turns is equal to 144 into 10 by 2. 10 by 2. Turns per phase. Turns per phase TPH is equal to 144 into 10 by 2 into 3 is equal to how much? Total number of turns is equal to 240. Turns per phase is 240. 240. Okay. Right? Okay. I will write this diagram tons. A bigger diagram, let me draw. See, this is one slot, another slot. Okay. In this is one coil having how many turns? 5 turn coil. 1, 2, 3, 4, 5. This is one coil, and this is another coil. This is also 5 turn. This is also 5 turn. Right? See, this is 5 turn coil. This red color is 5 turn coils. Black color also 5 turn coil. 5 turn coil. Right? Now each coil side has 5 conductors. 5 conductors. Each coil side or layer, each coil side or layer, each coil side or layer, 5 conductors. Remember that coil side is called layer. Coil side is called layer. Whenever you say, get a doubt, coil side is a layer. Each coil side has 5 conductors, correct? Yes. The 5-turn coil. Therefore, how many 2 coil sides are there? 2 coil sides are layers. Layers in each slot. Therefore, 10 conductors per slot. 10 conductors per slot. Okay? Right. Yeah. Now I will ask the last question and tell me answer. We will close this problems on this. And after do some problems, if you get any doubt, we will see. This is completed now? Okay. See. Listen. In this question, dear students, I will ask one question. In this, instead of double layer winding, if it is a single layer winding, what is your answer? Single layer winding. Single layer winding. How many turns? Same data, only single layer. Okay? See, in the above problem, in the above question, if it is a single layer, then TPH is equal to how much? TPH is equal to how much? Okay, data once again I will write. What is that? A 3-phase, 10-pole, single layer winding. 10-pole, single layer winding. Single layer winding. Each kind of total slots. 144 slots. The single layer winding. Single layer winding. Each coil has how many? Each coil has 5 conductors, or each slot 5 conductors per coil side. Each coil has 5 conductors. Each coil side, what is it? 5 conductors per coil side. Yes, 5 conductors per coil side. Per coil side. Okay. Yeah, I will ask after this. I will ask you. Ask 2 doubts. Okay. Just let me complete. After that, I will come to your doubts. A 3-phase 10-pole 144 single layer winding coil side. What will be that? Here, important thing is always you have to see single layer winding, 5 conductor per coil side. It's diagram if you are able to do. Single layer winding. This is a single layer. How many slots? Up to 144 slots. 144 slots. Single layer. How many conductor per coil side? This is one coil side. Only 4. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 4, 5. Okay? Yes. So, this is one coil side. Na? These are said to be coil sides or layers. Coil sides or layers. Coil sides or layers. layers. And how many conductors are there? Each layer, 4 conductor, 5 conductors only. Here also 5 conductors. 5 conductors. 5 conductors. The meaning is, this is like this. Only one coil is there. One layer, a single layer, so having again 5. One is there, only one layer. This is only coil side, no? Yes, this is the coil side. Layer. Layer. This is also 5-turn coil. 5-turn coil. 5-turn coil. But in each coil side, 4 conductors. In each coil side, 4 conductors. 5 conductors. 5 conductors. 5 conductors means what is the total number of conductors? 5 conductors. Total number of conductors. 144 into 5. Then tons, total tons. Total number of tons. 144 into 5 by 2. By 2. Tons per phase. 144 into 5 by 2 into 3. Okay. It is going to be how much? It will be exactly half of that. Na? Earlier, how many you have got? Earlier, you have got 240, but now it becomes 120, no? 120. 120. Is it 120? Yes. Now I will attend your doubts. Okay. Why I am saying all these things? When you are doing the problems, mainly students will raise a doubt here on this. That's the reason I am discussing. Okay. Raise your hands. Now let me discuss. Yeah, tell me. Bharat and Ashish Raj.
Hello, sir.
Tell me. Hello.
Sir, you told that number of in that double layer question, you told that number of coil is equals to number of slots, sir.
That will be always valid. Where is that? Tell me which question.
Sir, in previous classes.
Yes, yes. Yeah, correct only.
Sir, by using that method, sir, if I assume that total number of conductors is equals to 144 into 5, sir, means I solved by that way. There means it's wrong.
Which one? Where? Tell me. Here.
Previous. Yes.
This question.
No, sir. The turns per phase only, sir.
Turns per phase.
The double layers.
This one slide you see. Tell me. This slide.
No, sir. The turns per phase means second last questions. Yes, sir. Yes, sir. This one only.
Tell me.
Sir, here you have written 5 conductors per coil side.
Oh yes, 5 conductors per coil side.
Sir, I want to use that formula. The number of coil is equals to number of slots.
Yes, 2 slots I have taken here. How many coil sides are there? This is one coil side. Here, students. This is one coil side. This is one coil side. This is one coil. Okay, this if I keep here 1 dash, say this is 2 dash. Number is sufficient. Na? Double layer winding, number of coils, number of slots same. I am taking 2 slots, so 2 coil sides are there. That relation always valid. Do 5 conductor per coil side, okay. And your doubt is how did you calculate it? 145 conductor per coil side means 144 slots means 144 coils. That is your doubt, na?
Yes.
Number of coils is equal to number of slots. Okay. How many? 144. Accepted. Fine. 144 coils are there.
Yes, sir. Yes, sir.
But
Yes,
how
sir.
many number of conductor per coil side?
Okay, so that is 10.
Huh?
Yes.
How many coil sides? Coils are 144. How many coil sides? Coil sides will be double into 2 because each coil will have 2 sides. Correct or not?
So that it's a little bit confusing, sir. That's why I'm confused. Okay, sir.
No. That's the reason I am giving all this. And don't remember blindly that formula. That formula will be always valid. Always valid. Number of conductors, number of coils is equal to number of slots. That will be valid. 144 say okay. Number of coils, number of 144. Coil sides. How many coil sides? 144 coils are there. How many coil sides will be there? Tell me.
2 into 2 multiplied by 2, sir.
Into 2 number of coil sides. Okay. By conductors per coil side. Total
Yes,
number of conductors is equal to 144 into 2 into 5.
Yes,
That is
sir.
itself 144 into 10. Na?
Yes, sir. I was assuming this coil side to be 144 only, not multiplying by 2.
That's what I am repeating. Each coil will have 2 sides. Each coil.
Okay, sir.
Now I hope it is clear for you, na?
Yes, sir. Yes, sir.
Same 144 into 10 only came. Total number of conductors you see here and here. Okay? Yeah, right.
Yes, sir. Thank you.
That's the reason you draw the diagram like this. To draw a diagram like a simple diagram, then you can identify. That's the reason I am saying, because generally students will raise a doubt. Okay, next. Hello, Sangamitra, Ashish Raj. Hello.
Hello, sir. Good evening, sir.
Tell me.
Yes, sir. Just now my doubt was clear. Yes.
Very good. I hope whatever you do, dear students, you should know clear idea about what is coil and coil side. Each coil side means a coil can have any number of turns. Dear students, a coil can have any number of turns. Coil side means each coil will have 2 sides. That 2 sides means layer. This is one side of the coil called layer. Coil side is called layer. Okay. Yes. Next. Anyone? Hello.
Hello, sir.
Tell me, ma.
Total number of tons, sir. 144 into 5. How will become 2, sir? By 2 tons.
Tons. Conductors. 2 conductors are there. How many tons you will get? Tell me. 1 ton. 2 conductors are there. How many tons will be there? How many tons you will form? This is 1 conductor. This is 1 conductor. How many tons you will form? Tell me. Only 1 ton.
1 ton.
Under 2 conductors is equal to will form 1 turn. Okay.
Yes,
For
sir.
example, now 100 conductors are there. How many tons will come? 50.
50. Okay.
50 tons. Okay.
Yes, sir. Okay.
Now I want
Sir.
number is conductors are there. Tons means how many? Divided by 2 you have to do. 100 number of conductors is equal to, I can write number of conductors is equal to 100. Number of tons, how many? Tell me. 100 by 2.
100 by 2.
By J. Number of tons will be less always. Tons will be half. Number you have to see. Number.
Okay, sir.
100 conductors are there. It will be only 50 tons. Right. Yeah. Next.
Sir.
Anyone?
Previous class, one doubt, sir.
Previous class you can ask later, ma, in doubt session.
Okay, sir.
We will go in the mood of next last class. Okay, next.
Okay,
Hello.
sir.
Yeah.
Hello, sir. Hello, sir.
Tell me.
Sir, as we discuss in DC machines, there instead of taking turns, they're taking conductors. Why we don't take conductors rather
You
than
can
turns?
take anyway. Here also you can get the questions in the form of conductors also.
Okay, sir.
It can be given like there also each coil will be there, coil sides will be there, tons will be there. You mean equation? Equation E is equal to 5Zn by
Yes, sir.
60
Yes,
P
sir.
by A.
5Zn by 16.
That is okay. EMF equation is same. Even if you want, I can prove it. E is equal to 4.44 Kp Kd phi ft. That will be same. That is also equal to 5Zn by 60 P by A. But only Kp is equal to 1 for DC machine. Kd is equal
Yes,
to
sir.
2 by pi. Kd is equal to 2 by pi. Okay.
Okay, sir.
And
Thank
tons
you.
per parallel path you have to take. Tons per parallel path is equal to Z by 2 into 1 by P. You can take anywhere. Conductors, whatever you want, you can take. Okay. Yes.
Okay,
Now,
sir. Thank you, sir.
yeah. Then let us go for the next topic. Okay. Yeah. Let us go to the next topic. I hope you do practice problems. In the material, I have given sufficient number of problems. Dear students, you just to go through that and it will be clarified. Okay. And before starting the class, next topic, some of the students are asking, sir, 9:30 it is difficult to stay. So from here onwards, what I want to do, class timings will be 5:30 to 9 only. I will take 9. From 9 onwards, doubts. Okay, I will try to close 99% at 9 o'clock. So that because the people can go for lunch or dinner. Okay, fine. But anyhow, so if you want, I can take one extra class. We will cover. No problem. Okay. Yeah. Next topic is interested one. Dear students, be ready. Be ready for that. Okay. The next topic is, see. Oh. Sorry. Next topic is uniformly distributed winding. Uniformly distributed winding. Uniformly distributed winding. Uniformly distributed winding. If the number of slots, very important topic. If the number of slots per pole per phase, that is SPP, number of slots per pole per phase is large, then the generated EMF will be more sinusoidal. Then the generated EMF will be more sinusoidal. The generated EMF will be more sinusoidal. More sinusoidal. Then the winding is said to be. Then the winding is said to be. Winding is said to be uniformly distributed winding. Uniformly distributed winding. The number of slots per pole per phase is large. Then the winding is said to be uniformly distributed winding. The distribution factor for uniformly distributed winding. For uniformly distributed winding. Say that is KDU. KDU is equal to sine m gamma by 2 divided by m sine gamma by 2. Not m sine gamma by 2. Sine m gamma by 2 divided by m gamma by 2 into pi by 180. Pi by 180. KDU. Sine m gamma by 2 divided by m gamma by 2 into pi by 180. Pi by 180. Distribution factor for uniformly distributed winding. Uniformly distributed winding. Okay. Actually, how this relation is coming into picture? Okay, if number of slots per pole per phase is large, dear students, see, Now, earlier we have taken slots per pole per phase. How many? 3 we have taken a 3, SPP 3. Instead of that, if you keep R phase winding in more number of slots, R phase winding 1, 2, 3, 4, 5, 6, more number of slots, then generated EMF is more sinusoidal. That I am going to show. The winding is said to be uniformly distributed winding. Uniformly distributed winding. Okay? Yes. The distribution factor is sin m gamma by 2 divided by m gamma by 2 into pi by 180. And how this relation is coming into picture, no derivation is required. See, actually what is KD? KD is equal to sin m gamma by 2 divided by m sin gamma by 2. Na? This is our equation. Sin m gamma by 2 divided by m sin gamma by 2. But when slots per pole per phase is large, if slots per pole per phase is large, then slots per pole also large. Slots per pole is large. Then what is gamma? Gamma is equal to 180 by S by P. E is small. E is small. Then gamma 180 by S by P. E is small. Okay. Then sin gamma by 2 can be written as simply gamma by 2, na? Approximately. Yes. Sin gamma by 2 written as gamma by 2. Gamma by 2. Therefore, sin gamma by 2. Therefore, instead of gamma by 2, what we are writing? M gamma by 2. M gamma by 2. That's all. In place of sin gamma by 2, simply we are writing gamma by 2. Therefore, what is that? Entire thing will become m gamma by 2. But m gamma by 2, that has to be converted into radians. That has to be converted into radians. Correct? Because m gamma by 2 means m gamma 60, say 30 degrees. But in the numerator, sin 30, 0.5. 0.5 divided by 30 degrees cannot exist, na? Yes. Degrees has to be converted into radians. Radians. Okay. That is nothing but totally what is that? M gamma by 2. This entire thing will become what? M gamma by 2. M gamma by 2. Okay. This is m gamma by 2. So this is replaced with m gamma by 2. That's all. This is replaced with m gamma by 2. Okay. Right. On this basis, let us see some numeric objective questions. Objective questions. See, the questions are like this. Question is, the distribution factor for uniformly distributed winding. The distribution factor for uniformly distributed single phase alternator is A bit. Distribution factor for uniformly distributed single phase alternator is A bit 1 by pi, B bit 2 by pi, C bit 5 by 2, D bit 3 by pi. Distribution factor for uniformly distributed winding. A bit 1 by pi, B bit 2 by pi, C bit pi by 2. What is your answer? Yeah. Solution is for single phase alternator. Phase spread m gamma is equal to 180 degrees. Therefore, KDU, you have to find uniformly distributed winding, na? Yes, winding is uniformly distributed. Therefore, KDU is equal to Sin m gamma by 2 divided by m gamma by 2 into pi by 180. Pi by 180. That is equal to how much? M gamma 180, na? Yes. So that is sin 180 by 2 divided by 180 by 2 into pi by 180. Pi by 180. What is that? This is 1 and this is pi by 2. Pi by 2 is equal to 2 by pi. Right? 180, 180 will get cancelled. That is equal to 2 by pi. 2 by pi is your answer. 2 by pi is your answer. Okay? Yes. Now, similarly, another question. The distribution factor for uniformly distributed three-phase alternatories, same options. A bit 1 by pi, B bit 2 by pi, C bit 3 by pi, D bit pi by 3. So you can do that. It will be 3 by pi. Why? Because m gamma is equal to, you have to take 60 degrees. Correct? You will get it. And you can do it. I don't want to. You know that. Same thing. Sin 60 by 2. You can get it. Now, next question. Another question is, okay, you have taken na? Right. So next question is, an alternator, a single phase uniformly distributed alternator. Single phase uniform distributed alternator has T single turn coils. The EMF per turn is equal to 2 volts RMS. Then the total EMF is A bit 2 into T volts, B bit 1.273 into T volts, C bit 1.732 into T volts, D bit 1.414 into T volts. Question is clear now? A single phase uniformly distributed alternator has T single turn coils. The EMF per turn is 2 volts RMS. Then the total EMF is 2 into T volts, 1.273 into T volts, CB 1.732 into T volts. Okay. Yeah. Let us see the solution for that. Single phase uniform distributed alternator has T single turn coils. Since it is a single turn coils, important thing is T single turn coils are there, but EMF per turn is 2 volts. Each turn it is 2 volts, na? Each turn 2 volts. But how many turns are there? EMF per turn is 2 volts. Getting my point? It is given EMF per turn is given, dear students. EMF per turn is 2 volts. 2 volts. But how many turns are there? It is given T single turn coils. But for single turn coils, number of turns is equal to number of coils. T coils also equal to T turns. Single turn coils. See, since it is a single turn coil, so it is single turn coil. For single turn coils, this is a single turn coil, say. Single turn coil, this is said to be single turn coil. Single turn coil. Okay. Single turn coils means how many turns are there? How many coils are there? One coil. Here one coil. One coil means how many turns? One turn only. One coil is there, one turn. Single turn coils. One coil, one turn. How many conductors? 2 conductors. Here 2 conductors are there. 2 conductors. Single turn coil. Or if it is 2 turn coil, say for example 2 turn coil. 2 turn coil. 2 turn coil means each coil will have 2 turns. This is it is a 2 turn coil. 2 turn coil. 2 turn coil. How many coils are there? One coil. It is only one coil. One coil. How many turns are there? 2 turns are there. How many conductors? 4 conductors. 4 conductors. Okay, the 4 conductors. If you take 3 turn coil, 3 turn coil, 3 turn coil. For 3 turn coils, is 1 turn, 1 turn, 2 turns, 3 turns. 3 turn coil. Yeah, 3 turn coil. 3 turn coil, how many slots are there? How many coils? One coil. This is only one coil. Number of turns? 3 turns are there. How many conductors? 6 conductors. 6 conductors. 6 conductors. Huh? 6 conductors. Right? This is only called coil side. This is only called what? This is coil side. This is another coil side or layer. This is also layer, coil side or layer. Like everything. Okay. For your information, a coil can have any number of turns. A coil can have any number of turns. More turns are there, more conductors. So whatever the diagram I have drawn, one coil only I have drawn. One coil only. But first one is single turn coil, 2 turn coil, 3 turn coil. But 3 turn coils means number of conductors are 6 conductors are coming. 3 conductors left side, 3 conductors right side. Okay. But in this, it is a 3 turn. What is that? T single turn coils. Single turn coils, number of conductors, number of turns are same. Correct? Number of coils, number of turns are same. For single turn coil, is a single turn coil is given? Yes. So for single turn coil, number of coils is equal to number of turns. Number of coils is equal to number of turns. It is given number of coils is equal to number of turns. Battery ekkada hai? One minute. So actually, I forgot to keep. Yeah. Okay. Right. Fine. I forgot to battery now attached. Okay. See, for single turn coils, number of coils is equal to number of turns. Okay, that is equal to how many? T. Number of turns also equal to number of coils. That is equal to T is given. Earlier example, number of coils, number of T coils are there. T single turn coils. That is equal to T turns also. Since EMF per turn how much? EMF per turn is equal to 2 volts. RMS, 2 volts RMS. Then arithmetic sum. In each turn 2 volts, but T turns are there, T turns. T turns means arithmetic sum how much? 2 into T. Each turn 2 volts, but T turns are there, T turns means 2 into T. Arithmetic sum. Arithmetic sum is equal to 2 into T volts. 2 into T volts because T coils are there, na? T coils are there. That's the reason 2 into T volts. If the winding is concentrated, the winding is concentrated. The winding is concentrated. But the winding is distributed, na? Winding is uniformly distributed. Earlier you see, winding is uniformly distributed. Uniformly distributed means it is vector sum, correct? Vector sum. Winding is distributed. Vector sum is equal to KD into arithmetic sum. Arithmetic sum. If the winding is distributed, the winding is distributed. Correct? Because we know KD is equal to what? KD is equal to vector sum by arithmetic sum. KD is equal to vector sum by arithmetic sum. So if you want to write vector sum, KD into arithmetic sum. KD into arithmetic sum. But what is the KD we have got? KD is equal to 2 by pi. Single phase alternator. 2 by pi we have got. 2 by pi. Arithmetic sum 2T is equal to how much? It is 4 by pi. 4 by pi into T. That is equal to 1.273 into T volts. Therefore, answer is B. B is the answer. 1.273. 4 by pi into T. Okay. Right. Now I will ask one question for you, dear students. Now taken this now. Now question is, instead of single turn coil, if I ask here T instead of single turn coil, T 2 turn coil, what is your answer is going to be? T 2 turn coil say. Single turn 2 T turns coils. T 2 turns coils. Voltage is going to be double. EMF per turn 2 volts means each coil you will get 4 volts. 4 volts. You just try it. Okay. Right. Now, last question. See, based on this question will be based on the winding factor. Winding factor KW. KW is equal to KP into KD. KP into KD. Remember that winding factor. Sometimes he is asked to calculate winding factor. KP into KD. For this, let me give one question. One question. For each model, one question I am giving. That will be sufficient. Question is a 3-phase, 4-pole, 48 slot alternator. 48 slot alternator. Is short pitched by 1 slot. Is short pitched by 1 slot. The short pitched by 1 slot. Then the winding factor is. A bit. Cos 7.5, B bit. 1/8 sin 7.5 degrees, C bit. 1/8 cot 7.5 degrees. Cot 7.5 degrees, C bit. 1/8 tan 7.5 degrees. 1/8 tan 7.5 degrees. Okay. Answer is, let us see. The solution, you need to calculate KP and KD, substitute here. Substitute in the relation. Slots per pole per phase. Slots per pole per phase. That is SPPM. M is equal to how much? 48 slots are there. Slots per pole 4, per phase 3 is equal to 48 by 12, 4. Gamma how much? P into 180 divided by S. So P is 4 into 180 divided by S. S is 48. That is equal to how much? 15 degrees. Gamma 15 degrees. Gamma 15 degrees. Then what is KD? KD is equal to sine M gamma by 2 divided by M sin gamma by 2. M sin gamma by 2. So therefore, sin M is how much? 4. 4 into gamma by 2 divided by M sin gamma by 2. 4 into sin 15 by 2. That is equal to how much? This is sin 60 by 2, na? Yes. This is sin 60 by 2. Sin 60 by 2 is equal to how much? 1 by 2, na? Sin 31 by 2 into 4 sin 7.5 is equal to 1/8 into sin 7.5. 1/8 into sin 7.5. Now similarly, KP, calculate KP. Alpha is equal to 1 slot. Short pitched by 1 slot, na? Yes, alpha is equal to 1 slot. 1 slot means how much it is? 15 degrees. 15. Then what is KP? KP is equal to cos alpha by 2. Cos 15 by 2. That is equal to cos 7.5 degrees. Cos 7.5. Then KW is equal to KP into KD. So KP is a cos 7.5 degrees into KD is equal to 1/8 sin 7.5 degree. That is equal to 1/8 cot 7.5 degrees. Okay. So answer will be 1/8 cot 7.5 degrees. That is answer. KP into KD. So these are the type of questions in competitive examinations. Yeah. Now, let us see. Taken? So you do practice some problems. EMF equation problems is one of the important discussion. So there are 6 type of problems in alternator, 6 type of problems. One type of problem is EMF equation. Fine. Now, let us go to the next topic. It is advantages of distributed winding. Advantages of distributed winding. Advantages of distributed winding. Advantages of distributed winding. The main advantage of distributed winding, elimination of harmonics. The main advantage is harmonics elimination. But let us see how harmonics are eliminated. Harmonics are eliminated. Okay. Let us take comparison with concentrated and distributed winding. First, the main reason for the production of harmonics is non-sinusoidal flux distribution. Correct? Non-sinusoidal flux distribution. See, very beginning class I have given. The main reason for the production of harmonics is non-sinusoidal flux distribution in the area. For example, if you take, this is the North Pole, or it may be any pole. Okay. The North Pole. This is a pole, na? Yes. North Pole. We are expected flux distribution as sinusoidal, na? How flux distribution? This is a flux distribution. Flux distribution. So if you draw the variation of flux distribution B wave, it is sinusoidal. We are expected it is sinusoidal. Expected it is sinusoidal. Sinusoidal. But at the center, what will happen? Air gap is less, na? Therefore, more flux will try to pass this area. Most of the flux crowded at the center of the pole. Crowded center of the pole. Therefore, this pole will tend to saturate. Center of the pole will tend to saturate. Now, how you will get it? This is going to be flat. You will get flat. You will get flat. Flat topped wave. Flat topped wave. We are expected sinusoidal, but you cannot get exactly sinusoidal. You cannot get sinusoidal. How it is going to be? You will get a flat topped wave. Flat topped wave. Actually, we are expected sine wave, but your diagram will be like this: flat topped wave due to saturation. Therefore, the main reason for the production of, when B wave is like this, E wave also same. The main reason for the production of harmonics is non-sinusoidal flux distribution. Non-sinusoidal flux distribution in the air gap. Non-sinusoidal flux distribution in air gap due to saturation. Due to saturation. Fine. So EMF in each coil is a flat topped wave. You cannot get sine wave. In each coil, you will get flat topped waveform only. You cannot get sine wave. Okay. Let me compare concentrated winding and distributed winding. Advantages of distributed winding means compared with what? Concentrated winding. So let us see for both concentrated winding and distributed winding. It is concentrated winding, say. I would like to compare concentrated winding. For concentrated winding, these are the three slots. For example, these are the three slots. 1, 2, and 3. The three slots say. Okay. These are the three slots. For concentrated winding, we will keep all the coil sets only in one slot. We will keep all the coil sets only in one slot. Na? Yes. This is 1, 2, and 3. That is a concentrated winding. R1, R2, R3. All they will be kept in the same slot. Same slot. So when we are keeping all the coil sets in same slot, if you take, this is induced EMF is E1. The induced EMF is E1 and E2, E3. E1, E2, E3. And three coils are connected in series. We are connecting three coils in series, say. Coil 1, coil 2, coil 3. Three coils are connected in series. This is E1, E2, E3. How resultant voltage? This will be the resultant voltage. Resultant voltage. Three coils connected in series, na resultant voltage. But EMF for each coil, they are cutting the flux distribution as flat topped wave. The flux distribution is flat topped wave. Generated EMF also flat topped wave. Generated EMF in each coil, flat topped wave. You will get like this. EMF per coil. This is in coil 1, say. Coil 1. Then coil 1. And second coil also in same phase. No? Second coil also in same phase. Second coil also in same phase. Third coil also in same phase. All three coils are kept only in one slot, means there is no phase difference. All they will be in same phase. All they will be in same phase. That the E1, E2, and E3. All they are in same phase. There is no phase difference. No phase difference. Then if you draw the resultant voltage, how it is going to be? Resultant. The resultant will be three coils connected in series, na? Instantaneous values. I am taking form of waveform. The instantaneous values. At this point, all they are 0. Correct? At this point, all they are 0. If you take here, how much? All they are 3, 3, 3, say 3 volts, 3 volts, 3 volts, 9 volts, 9 volts. Similarly, if you take here at this point, all there are some 8 volts, say 24 volts, 24 volts. If you take at this position, all their maximum, it is said to be 30 volts, 30 volts. And up to here, it will be 30 volts, 30 volts. similar points. If you take similar points, this will be again 24 volts, 8, 8, 8, 24. Here 3, 3 say, 3, 3 C means 9 volts. It is 0, 0. If you join all these things, it will be again flat topped wave only. You will get again flat topped wave only. This is ER, resultant voltage. That is also flat top, consisting of all harmonics. All harmonics are there, no harmonics are eliminated. Only magnitude has increased. Magnitude only increased. Wave shape is not improved. Consisting of harmonics. But if you take distributed winding, see, for the same thing, if you take distributed winding, winding will be distributed in 3 slots. Distributed winding. Distributed winding for the same. We are going to distribute the winding. If you distribute the winding, one coil side is kept in one slot, other coil side is kept in another slot, like this. This is E1. They are having phase difference, na? Yes, this is E1, E2, E3. Phase differences are there, phase differences. And all 3 coils are connected in series. These 3 coils also connected in series. One, E1, E2, E3. E1, E2, E3. Now resultant will be, this is ER. Resultant is ER. Resultant is ER, no? Yes. Whereas in each coil will cut the same flux distribution. Each coil will cut the same flux distribution. Therefore, here also E1 or E2, whatever it may be, it is flat topped wave that you cannot change. It is cutting same. Each coil induced EMF same shape only, as it is cutting flux distribution. But they will have only phase difference. Phase difference. See, this is in coil 1 is the induced EMF. Coil 1 induced EMF. E1 say. This is E1. Other will have phase difference. They will have a phase difference, not in same phase. Phase difference. Okay. This is second coil. This is also flat topped wave, second coil. Similarly, third one will have phase difference. This is the third coil. Okay. If you want, you can also extend like this. This also like this. Okay. If you take, this is E1, this has E2, and this is E3. But there is a phase difference, na? There is a phase difference between each and every one. This is gamma. Gamma. This is also gamma. Why? Phase difference will come into picture. From this to this, it will be gamma, na? Yes, this is gamma. So phase difference will come into picture. Gamma. If you add resultant of, are you getting? This is E1, E1. Seeing highlighting M. This is E1. E2 will have some phase difference. Anyone you can take reference. E2. This is E3. All they are flat only, flat top wave only. Okay. Let us see resultant voltage. Resultant will be, add all these voltages. At this instant, this is positive, E1 positive, but E3 negative. E3 negative. For example, E1 some 7 volts positive, say 7 volts positive, but E3 7 volts negative. What is the net voltage? 0. E2 anyhow 0. So plus 7 minus 7, 0, na? E2 anyhow 0. Similarly, if you take another point, let us take this point. Here this is 9 volts, say. E1 is plus 9 volts and this is some 4 volts, say. 9 plus 4, how much? 9 plus 4, 13. 13, if you say 13, this is some 7 volts. 13 minus 7, 6 volts. That will be 6 volts, 6. Similarly, take here at this position. What will happen? This is 10 volts. This is E1 is plus 10, maximum plus 10. This is some 6. 10 plus 6, 16. 16 minus 4, 12 say. Just like that, I am taking numerical. Don't worry about that. Sir has taken 12, I am getting only 10. Likely, I am taking instantaneous value, instantaneous. Take at this position. At this position, what was happened? E1 and E2 both are 10 plus 10, 20. Both are maximum positive, 20. 20 plus some 5 say, 25. It will be 25. Similarly, take at this position. At this position, these two are 10 plus 10, 20. 20 plus 7, 27 say, 27. Similarly, here it is 30 volts. 30 volts. Okay. And all they are 10, 10. Na? E1 is 10, E2 10, E3 10, 30 volts. Likewise, if you take on this side also, I have taken on this side, even for other side, symmetrically I am drawing. I don't want to count everything. Okay. Like this. Okay. Join all these things. How you will get? This is ER, resultant. Now observe how difference between this concentrated and distributed winding. Each coil is flat topped wave. Saturation takes place. Each coil flat top, but resultant is when concentrated, it is totally again flat top. All harmonics are there, but next one sinusoidal harmonics are said to be eliminated. Only we are distributed 3 coils, dear students. Only 3 coils we are distributed. This much improvement is there in the waveform. This much improvement is there. Instead of that, if you take more number of coils, R phase winding is kept not only 2, 3 slots. If you distribute 3, 4, 5, 6 slots, more slots means what is going to happen? More sinusoidal. That is called what? Uniformly distributed winding. Uniformly distributed, if you distribute more number of slots, that is going to be more sinusoidal. Okay. So from these 2 diagrams, I proved that distributed winding is generated EMF waveform is improved. Okay. Can you tell me? You see the 2 diagrams are there now. One is left side, one is right side. What is happening inside exactly? With the distributed, why EMF is increased? Sorry, why EMF waveform is improved? Why it is improved? Why? Because phase difference. Phase difference is beautiful. In this concentrated, all waveform flat topped, all their overlap. There is no phase difference. All their overlap. Overlap means the flat is maintained as it is. But for distributed winding, what was happened? Though they are flat top, E1, E2, E3, but they are having phase difference. Na? E1 to E2 gamma, E2 to E3 gamma. In that business, what is happening, dear students? See, observation is, this is E1, this is E2, E3. But their instantaneous values are not equal at the same time. Their instantaneous values are not same. At this point, it is 0. Here, what is happening? One is positively increasing, another one is negatively decreasing. And here, one is reached maximum, but other one still increases. E1 reached maximum, E2 still increases, but E3 negatively decreasing. Similarly, here, E1 and E2 reached maximum value. E1 and E2 reached maximum value. but E3 still increases. Like that, at the center, all their maximum. Okay, their instantaneous values. So one is positive, one is positively increases, one is positive, other one negatively increases. One is reached maximum, another one is still increases. Like that, on overall voltage, resultant voltage among all three coils together, you are getting a sinusoid. I want resultant. Each coil flat top, but resultant is sinusoidal. That is what it is required. Okay. Yeah. So harmonics are said to be eliminated. Now let me list out advantages one by one. What is the first advantage? Effect of harmonics are eliminated. I am writing all advantages. Number one, first one, advantages. Harmonics are eliminated. Harmonics will be eliminated. Will be eliminated. Therefore, generated EMF is more sinusoidal. Generated EMF is more sinusoidal. More sinusoidal. Second one, with the elimination of harmonics, iron losses are reduced. We are eliminated means iron losses are reduced. With elimination of harmonics, iron losses will reduce. Iron losses will reduce. Iron loss will reduce. Third one. Third advantage is, listen. Third advantage, in distributed winding, what we are doing? Sorry. In distributed winding, all the winding is distributed in all the slots. Na? Armature winding is distributed all the slots. Of course, I am taking only 3 slots. Like entire periphery, armature winding is distributed in all the slots. By distributing, armature winding is mechanically balanced well. Armature winding is mechanically balanced well. But whereas in concentrated, all coils are kept only in one slot, R phase. And second slot, third slot, it is empty. So when empty means weight is more in the first slot and these are empty slots. Winding is not mechanically balanced well. So distributed winding is mechanically balanced well. Winding is more rigid. Armature winding is more rigid since all slots are occupied with the coils. So armature winding is mechanically balanced well. Armature winding is mechanically balanced well. Mechanically balanced well. Armature winding is mechanically balanced well. That is, winding is rigid. Winding is rigid. Okay. Winding is rigid. Next, let us see fourth one. Since we are keeping armature winding in all the slots, cooling is effective. Cooling is easy. By entire surface area is utilized. That is also one. Armature core is effectively utilized. Since armature winding is kept in all the slots, total 360 degrees we are utilizing. So armature core is effectively utilized. Armature core is effectively utilized. Armature core is effectively utilized. Effective utilization of armature core. Since entire armature winding is kept in all the slots. Since armature winding is kept in all the slots. Okay. Effectively utilized. And fifth one, armature winding can be cooled effectively. More surface area, entire surface area is utilized means, so more surface area means better the cooling. Na? Distributed winding, we are keeping winding in all the slots. So fifth one is cooling is effective. Cooling is effective. Since entire surface area is utilized. Entire surface area is utilized. Entire surface area is utilized. More surface area, better the cooling. Na? Yes. Entire surface area is utilized. Okay. And next, see here. In two cases, if I keep, this is also 30 volts, na? If I keep this diagram in this, it is going to be sinusoidal. For example, sinusoidal, say. What I am doing, if I keep the diagram here, that is also 30 volts. Of course, right side, by default it is, I have drawn bigger one. This is also 30 volts, na? Maximum value 30 volts. Here also maximum value 30 volts. If you keep this waveform inside of this, okay, this is that much. This is 30 volts maximum. Can you tell me in two cases which will have more average value of flux? This is the current waveform, say, which will have more average value of flux? Flat top. Flat top area under the curve is more. Sinusoidal area is less. Sinusoidal area is less. When winding is distributed, armature current waveform sinusoidal for same maximum value, it will produce the less armature flux. Armature reaction is less. Armature reaction is less. This is a, so 2 years back we can find question in IES examination. Net armature flux is reduced, therefore armature reaction is less. The sine wave, this is a flat topped wave. Sine wave will have less average value compared with this flat topped wave because area under the curve is more, no? Flat top, sinusoidal is less. So sixth one is less effect of armature reaction. The average value of flux. Average value of flux for distributed winding is less. For distributed winding is less. Okay. Therefore, less effect of armature reaction. Less effect of armature reaction. Less voltage drop. Less voltage drop. Therefore, better the regulation. Dear students, better the regulation compared with concentrated. Regulation is better. So these are the advantages. All these are the advantages. Very important, all these things. Multiple select answers, na? MSQs is checking the ability of the students. He's giving 4 options and is asking, you should have knowledge about all 4 options. Whether the options are given is right or wrong. These are the advantages. Okay. Then what is a disadvantage? Disadvantage is small reduction in fundamental voltage. Small reduction in fundamental voltage. Small reduction in fundamental voltage because vector sum. How much? 3 to 4%. 3 to 4%. Because vector sum. Because it is vector sum. Vector sum always less than the arithmetic sum. No? Vector sum. Okay. This is the advantages of concentrated distributed winding. Okay. Yes. So with this, distributed winding is 100% completed. Now let us take the break for 20 minutes, and then we will start with the another topic, new topic. Okay. Let's take break for 26 now. Break for 20 minutes. Class will start at 7:27 to 7:47. Class again started 7:47. Take the break and come back. Don't worry, I will continue up to 9 o'clock only. 9 I will stop. Okay. After the doubt sessions. Okay. Yeah. So this is about the distributed winding. Now, then let us see the next topic. Yeah. Next one is, I just want to draw the double layer winding and single layer winding. Double layer and single layer winding. Single layer winding we have drawn. Based on the double layer winding, there will be some questions. What are that? In double layer winding, for full pitch winding or short pitch winding, how many number of slots both top and bottom layers can be placed? Top and bottom layers can be placed. So yesterday we have drawn for single layer winding. Now let us see exactly what is the meaning of double layer winding. Double layer winding. See, based on this, some typical questions that we are going to see. Double layer winding. Double layer winding for 60 degrees phase spread. Say, I would like to take for 60 degrees phase spread. For 60 degrees phase spread. 60 degrees phase spread. For this, let us take an example of a 3-phase, 2-pole, 18 slot alternator. 18 slot alternator. 18 slot alternator. Very typical question that we are going to see. Very typical questions. 18 slot alternator. For this, what is slots per pole per phase? Slots per pole is 9. Slots per pole is 9. 18 by 2, 9. Slots per pole per phase? Slots per pole per phase. SPP. How much it is? M2. 3. Slot angle gamma? Gamma is equal to P into 180 by S. That is 2 into 180 divided by 18. 18. 20 degrees. 20 degrees. Okay. 20 degrees. See. 18 slots I am taking. 18 slots. Slot 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 and 18. Okay, yes. So this is 1, slot 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And to add one more slide on this side, just a minute. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 slots. Okay. These are 18 slots. For this, gamma how much? Gamma is 20 degrees. 20 degrees. Now for keeping the winding, see, For keeping the winding, R1 slots per pole per phase, how much? 3 slots per pole per phase, 3. So R phase winding, I can keep R phase winding R1, R2, R3 in the top layer winding. R1, R2, R3 in the top layer. Beginning R1, R2, R3, where other side must be kept full pitch winding. Let us draw full pitch winding. 1 plus 9 together, 10, 10th slot. 10th slot means R1 dash, R2 dash, R3 dash can be kept here. R1 dash, R2 dash, R3 dash. Top layer, this is bottom layer. R1, R2, R3. Next, where Y1, R1 to Y1 must be 120, na? 120. 120 means 7th slot. Okay? Slot 1 to slot 7, 6. 6 into 20, 120. So Y1, Y2, Y3 can be kept here. Y1, Y2, Y3 can be kept here. Where Y1 dash, Y2 dash, they will be 16, 17, 18. Just like yesterday example, 16, 17, 18. So here Y1 dash, Y2 dash, Y3 dash, Y1 dash, Y2 dash, Y3 dash. Okay? Yes. Now where B1 can be kept 7 plus 6, 13. 1 plus 6 is 7. R1 is kept in one slot. Y1 can be 1 plus 6, 7. 7 plus 6, 13. 13th slot, top layer. 1, 2, 3. B1, B2, B3, B3. Now other side, 4, 5, 6. Yesterday example only. Like same thing, it is a closed one. B1 to B1 dash 180. 180 means where we will keep 4th slot, 5th slot, 6th slot. So B1 dash, B2 dash, B3 dash. With this, we will come to an observation. With that, we will form the question. Okay? Yes. One set of winding was over. One set of windings was over. Then again, R1 to Y1, it is over now. Next again, R will start. Only half of the layers are completed now. Top layer, bottom layer, top layer, bottom layer. But in 1, 2, 3 slots, only top layer. Double layer winding means bottom layer also must be completed. So to keep bottom layer, what we will do is R1 to Y1, 120 na? RYB. This is R. You say R2Y 120, Y2B 120, again B2R also 120. R2Y 120 na? Yes. And Y2B also 120. B2R also 120. 120 degrees. Fine. Are you getting? R, Y, B. Again R. Yeah. R2Y 120 degrees. Y2B 120 degrees. B2R also 120 degrees. 120 degrees. So that's the reason where to keep this winding. R1, Y1. Listen carefully. R1, R2, R3, R3, R4. That is over. Now B1, B2 is over. Kada? From B1 to again second coil of R phase will start from B1. We are here B1 in 13th slot. Dear students, important point. 13 point. 13 to 2. Again 120. Where it will come? 13 to 2. See. 13. 20, 40, 60, 80, 100. 100, 120. 120 means again R will come here. Are you getting? R1, Y1, B1. Again B1 to again next R will start. Next R will start. But that R is equal to, see, R means it will be other group of coils. Let me call it is R4, R5, R6. R4, R5, R6. R5, R5, R6. Right? Yes. And where R4 dash, R5 dash, full pitch I am writing. Therefore, R4 dash, R5 dash, they can be kept here. R4 dash, R5 dash, R6 dash, R6 dash. Again B. Again B, Y. Y can be kept the bottom layer. Already top layers are there. R to Y also 120. But this is Y4, Y5, Y6. Y6. Now, Y4 dash, Y5 dash, Y6 dash, Y4 dash, Y5 dash, Y6 dash, Y4 dash, Y5 dash, Y6 dash. Again B. So Y4 to B4 also must be 120. Okay. Again, R4 to Y4 to B4 also 120 compulsory. So therefore, this is Y is there, and after that B can be kept here, bottom layers. B1, this is B4, B5, B6, B4, B5, B6. Again 180 degrees. Where it can be kept? Here. B4 dash, B5 dash, B6 dash, B4 dash, B5 dash, B6 dash. Important observation. You need not to draw the diagram entire thing. I would have given directly also, but people will question, sir, how it is coming. How it is coming means this much discussion it is required. Okay. See. In the examination, if you remember conclusions enough, dear students, when I have drawn for full pitch winding double layer, okay. For 60 degrees phase spread, we have drawn, of course. For 60 degrees phase spread is nothing but what? This is said to be phase spread. How much angle? This is phase spread. Phase spread. How much angle it will be? 60 degrees. This total 3 slots it is occupying means 60 degrees. Phase spread is 60 degrees. Okay. Yeah. Similarly, B also, this is also one phase spread. This is also one phase spread. Phase spreads there. For full pitch winding, both top and bottom layers. Important thing is, see, in the first slot, top layer R1, bottom layer also RR. Let it be R1 or R4, forget about. Top layer RR, bottom layer also RR. Fourth slot, BB. In all the slots, top layer, if Y phase say, bottom layer is Y phase only. Top layer R phase means bottom layer R phase only. Now all 18 slots, out of 18 slots, all the slots are occupied with same phases. If it is a full pitch winding. Okay. Yes. And if winding is short pitched, say, the conclusion is, if the winding is full pitched, for double layer winding, all the slots, both top and bottom layers, will occupy with same phases. Okay. Top layer R phase, bottom layer R phase. The winding is full pitched. For double layer winding, both top and bottom layers occupied with same phases. Similarly, let us see. If the winding is short pitched, say, the winding is short pitched, see here, winding is short pitched. Beginning of the coil is placed in the first slot R1, and where R1 dash can be kept, R1 dash instead of keeping 10th slot, it can be short pitched by one slot, say 9th slot. R1 dash we kept in the 10th slot for full pitch. 9th slot means it can be kept in the for short pitch 9th slot. So for short pitch winding, what is going to be happen? This R1 dash will come to here. R1 dash will come to here. Okay. R2 dash will come to here. R3 dash will come to here. Come to here. Are you getting? This is R1 dash, R2 dash, R3 dash, R3 dash. Okay. The meaning is, listen, let me write separately. For full pitch winding, in the two slots I am taking, let us take only for full pitch winding. For full pitch winding, right? Let us take a slot number, slot number 10, 11, 12, 10, 11, 12. Slot number 10, 11, 12. 10, 11, 12. So for earlier it is R, correct? You will get R4 dash, R5 dash, R6 dash, R6 dash. But for short pitch winding, this is R1 dash again, R1 dash, R2 dash, R3 dash. The three slots, this is for full pitch. This is for full pitch winding. Full pitch winding. I am coming to the conclusions. Okay. Both top and bottom layers are occupied with the same phases. Out of three slots occupied with same phases. Okay. Whereas, again, if you take for the three slots, when they are short pitched, again I am taking only three slots. Okay. 10th slot, like a 10th slot. 11th slot, 12th slots. Right. See, earlier in 10th slot, R4 dash is there, R5 dash is there, R6 dash is there, R6 dash. But when short pitched, what is happening? Here B4 will come to here. Here it will be B4. Okay. Observe with only 10, 11 slots. These are the how many slots? 10, 11, 12 only I am observing. For that, what is the bottom layer? Bottom layer for 10th slot will come R2 dash will come. Here, what is that? R2 dash. You will get R2 dash. And here it is R3 dash. Here it is B4 dash. So you will get here R2 dash, R3 dash, B4 you will get. Here it will be R1 dash. R1 dash is here. This is for short pitch winding. So you just observe with the three slots. Observe only with these three slots. What is happening here? Top layer positions are same. I am coming to the conclusion. Top layer positions are same here and here. Just compare these two. Both top layer R4 dash, R5 dash, R6 dash only. Top layer position never change. Why? Because R1 to Y1 compulsory 120, Y1 to B1 compulsory 120. Then automatically all phases. So top layer positions are same. For short pitch winding, bottom layer positions are shifted left side. Correct? Yes. But instead of 10th slot, we are keeping 9th slot. So 10th slot, coil will come 9th slot, and similarly 11th will come 10th. So bottom layer positions will be shifted left side by one slot. That is the main conclusion. So they are shifted left side, bottom layer. R1 dash in 10th slot, na? R2 dash in 11th slot, but R2 dash has came to 10th slot. So, important conclusion is when winding is short pitched. See, for full pitch winding, both top and bottom are occupied with same phases. But once winding is short pitched, if the winding is short pitched by one slot, the top layer positions will be same. Top layer positions will be same. Top layer positions will be same. But bottom layer positions shifted. Bottom layer positions shifted left by one slot. If the winding is short pitched with one slot. Short pitch with one slot. Okay. Bottom layer position is shifted left by one slot. Similarly, if the winding is short pitched by two slots means, if the winding is short pitched is two slots, the winding is short pitched. The winding is short pitched by two slots. Bottom layer position shifted by two slots. Left. Shifted left by two slots. Like that. Left by two slots. Okay. So after this much discussion, I will come to only conclusion. When winding is full pitched or short pitched, whatever you do, top layer positions are same, but bottom layer positions will be shifted left by one slot. If short pitched by one slot means one slot left shift. If it is two slot short pitched means we shifted two slots by left. With this conclusion, let me give questions. I will give the questions. This is another type of question. Okay. The question is like this. A three-phase 4-pole alternator. A three-phase 4-pole alternator is a previous GATE examination, GATE 2003 examination question. GATE 2003 for 2 marks. A three-phase 4-pole 36 slot alternator. 36 slot alternator with coil span. 36 slot alternator with the 60 degrees phase spread. 60 degrees phase spread. The coil span is 7 slot pitches. 7 slot pitches. Okay. Then the number of slots. In which both top and bottom layers. Top top and bottom layers occupied with same phases. Occupied with different phases. Different phases is A bit 12, B bit 24, C bit 36, D bit 48. 48. 48. Okay. Now you need not to draw for all 36 slots. If you draw the 36 slots, your examination time is going to be completed. Only for one question. Huh? Yeah. This question we are going to make single step. Yeah. And to have the clear idea, in the solution itself, we are going to get the answer for that. Not only this, I am making general questions, not only any slots. How many slots it may be short pitch. See, for this, you need not to do all the things. You only calculate slots per pole per phase. I will calculate only for one phase belt. One phase belt. Earlier, I am observing only 3 slots. I have shown here, na, this is only 3 slots I am bothering. 3 slots. Earlier also slots per pole per phase 3, na? Yes. So now also slots per pole per phase. How much? SPP. Slots per pole per phase is equal to SPP. M is equal to how much? 36 slots. Slots per pole per phase. 36 by 12 is equal to, it is 3. Okay. 3 slots. One phase belt only. Gamma anyhow 20. So one phase belt we will observe. First, full pitch winding, say. First, 60 degrees phase belt, full pitch winding. For full pitch winding. See, for full pitch winding, I will take both top and bottom layers. No? Top and bottom layers. Let us take only one phase belt. One phase belt is enough. Is 1, 2, 3. Fine. Top layer positions R. Now forget about R1, R2, R3, all those things. Simply R. Top layer R. Bottom layer also R will come. For full pitch winding, both top and bottom layers are occupied with same phases. Already we completed the conclusions. Correct? Conclusion has been given already. Okay? Yes. This is R. So among this, for 3 slots, three slots which out of 3 slots, 3 slots occupied with same phases. 3 slots occupied with same phases. Now for 36 slots, how many slots occupied with same phases? That is equal to 3 by 3 into 36. So therefore 36 slots occupied with same phases. Occupied with same phases. Occupied with the same phases. Okay. This is for full pitch winding. Full pitch. Now if the winding is short pitched, say winding is short pitched. When winding is short pitched, for short pitch winding, short pitched by 1 slot. Winding is short pitched by 1 slot. Short pitched by 1 slot. This is top layers R only, but bottom layer This will be with different phase. B will come, correct? Earlier diagram. So all are shifting left side, na? Yes. R1 to R1 dash 10, na? It is shifted left side, shifted left side. Okay. Well, shifted left side means it will come another phase. But R, this R will be shifted here. I have shown, na? Yes. R1 dash is shifted to 9th slot. It came that side. But I will bother about only how many slots? Same slots. This is the thing I am observing. Earlier also same phases. How many slots? Same phases. All slots with same phases. But now only 2 slots with same phases. 2 slots with same phases. Therefore, it is out of 3 slots, 2 slots with the same phases. 2 slots with same phases. 2 slots with same phases. 2 slots with same phases. For 36 slots, how many slots? For 36 slots, how many slots with same phases? They will be 2 by 3. 2 by 3 into 36. That is equal to 24 slots with same phases. 24 slots with same phases. Therefore, how many slots with different phases? Therefore, 12 slots with different phases. 12 slots with different phases. Different phases. 12 slots with different phases, correct? Yes. Now short pitched by 2 slots, say. Similarly, short pitched by 2 slots. Short pitched by 2 slots, also same concept. R. But now you can leave this slot. Now they will becomes like this. R. They are shifted left side, na? Yes. They are shifted left side. Bottom layer positions are shifted left side. The left side means out of 3 slots, only 1 slot with same phases. 1 slot with same phases. Out of 3 slots, 1 slot with same phase. 1 slot with same phases. But for 36 slots, how many? For 36 slots, how many? 1 by 3, 1 by 3. 1 by 3 into 36. That is equal to 12 slots with same phases. 12 slots with same phases. Okay. Therefore, 24 slots with different phases. 24 slots with different phases. (24 slots with different phases. (24 slots with different phases. Okay. Now see your answer. What is your answer? Answer is there already. We got in between procedure. Correct? Yeah. See here. No, your coil span, a 3-phase, 4-pole, 36 slot alternator, 60 degrees phase spread. Coil span is given how much? Coil span is given 7 slot pitches. But what is the slots per pole? Slots per pole. S by P is equal to 36 by 4. 9 slots. 9 slots for full pitch winding. For full pitch. But coil span is given. Coil span is equal to 7 slots. 7 slots means short pitched by how many slots? Short pitched by 2 slots. Actually 9 kada. Full pitch winding 9 slots, but short pitched by how many? 2 slots. 2 slots. Okay. Now for 2 slots, what is your answer? See, in this, how many slots short pitch? 2 slots. First one is short pitched by 1 slot, full pitcher. Second one is short pitched by 1 slot, and third one is short pitched by 2 slots. This is your answer. How many slots with the same phases? 12 slots, but different phases, 24 slots. 24 slots. That is our answer. So what is our answer? Answer is B. Answer is B. Therefore, answer is B. Answer is B. Okay, in this problem, I have solved all the possibilities. But when the examination is given, you not necessary to do all this procedure. Directly you can go. 3 slots are there, 2 slots short pitch. What is going to happen? Now I will give question. Now you have to answer within 1 minute. So this type of questions are going to be within 1 minute. Within 1 minute. See, ESE examination, ESE 2004 examination. This is previous ESE examination. ESE exam. Question is a 3-phase 4-pole 48 slot alternator. 48 slot alternator with a double layer winding. With a double layer winding. 60 degrees phase spread. 60 degrees phase spread. Is short pitched by 1 slot. Short pitched by 1 slot. Then the number of slots. Number of slots in which both top and bottom layers. Both top and bottom layers. Both top and bottom layers occupied with same phases. Occupied with same phases. Is A bit, 12 B bit, 24 C bit, 36 D bit, 48. Tell me now your answer. Within 1 minute you have to answer. 1 minute. After doing this much exercise, see. Okay. Yeah. What is the answer? Tell me, dear students. Tell me answer. Answer quickly. Both top and bottom layers occupied with. Very good. Very good. That's all. How many? Some people are saying 36. Some people are saying 24. What's your answer? The solution is slots per pole per phase calculate. Don't draw for all slots per pole per phase. SPP. How much M? M is equal to total slots are 48. Slots per pole 4 per phase 3 is equal to that is 4. 4. That's all. For that 4 only I can draw. For that 4, 1, 2, 3, 4. Okay. Top layers simply RRR. One phase belt is enough to write RRR. Short pitched by how many slots? 1 slot. 1 slot means leave this slot. Now R phase bottom layer shifted left side. They are shifted left side. R, R, R and R. But I will bother about only these 3 slots, same phases. I am doing based on the same phases. One R phase has gone that side. This side B phase will come. B phase will come under this. Therefore, now what is your answer? Out of 4 slots, 3 slots with same phases. 3 slots with same phases. Then for 48 slots. How many slots? It will be 3 by 4 into 48. 3 by 4 into 48. That is equal to 36 slots. 36 slots with the same phases. That is your answer. B. Okay. And if it is short pitched by 2 slots means, so 2 slots with same phases, another 2 slots with different phases. 2 slots and half of the slots with the same phases, half with different. 24 slots same, 24 different. If it is short pitched by another 3 slots say, like that. Now it is in the fingertip. No pen and paper also required for this problem. Solving these type of questions, no pen and paper is required. Correct? Yes. But coming to this conclusion, not that easy. How much time we spent? Okay, we broken our heads. Some people may be thinking, oh, what is this? Now, you forget about all the discussion, whatever we have made, okay, leave it. You can believe it, na? Otherwise, directly I am giving, you cannot believe. So hundreds of students are here, definitely they will question. Some people will question, sir, how it is coming. Then again, I need to explain. Okay? Yeah. During study, we need to face a lot of struggle. Okay? And once we have seen that, we have believed that, yes, top layer positions are same, bottom layer position shifted left side, 1 slot. If short pitch by 1 slot. 2 slots is there, 2 slots. That's all. We have believed, now you never verify it. Okay? Examination, bother about only this problem. That's all. Fine? Okay. This is one type. And last type of questions. In your examination, EMF equation E is equal to 4.44 kp kd phi ft. Kp kd phi ft. But sometimes he won't give phi, flux he won't give. But instead of that, flux density will be given. When flux density is given, then how to calculate the flux? Relation, flux is equal to 2dl by p into B max. 2dl by p into B max. Let us do that. See here. Here, students. Relation between flux and flux density. Relation between flux and flux density. Flux density. So flux is given directly, you can substitute, but flux density is given, you will give dimensions, diameter, length also will be given. At that time, what to do? You need to calculate flux to find the equation. Relation between flux and flux density. See. B average is equal to average value of flux is equal to flux density into area. Correct? Average value of flux. Average value of flux per pole. Average value of flux per pole. That is phi average is equal to B average into area under each pole. Area under each pole. area under each pole. So calculate phi average and B average. See, B average. Our flux density wave is sinusoidal, na? Our flux density is sinusoidal. This is the sinusoidal. B wave with respect to theta. Theta. So for this is B max. BM, B max. B max. Now what is B average? B average is equal to, this is 0, pi, 2 pi, na? 2 pi. So B average is equal to 1 by pi, 1 by pi. It is B is equal to Bm sin omega t. We can write B is equal to Bm sin omega t. B is equal to Bm sin theta. Sin theta. So it is 1 by pi, 0 to pi, B max sin theta. B max sin theta. Okay. That is equal to 1 by pi, B max. That is equal to 1 by pi, 0 to pi, or B max by pi, B max pi, what is that? Minus cos theta, na? Yes, minus cos theta, 0 to pi, 0 to pi, which is equal to B maximum by pi. This is minus cos pi, minus of minus cos 0, 0. Okay, that is equal to B max by pi, that is 1 plus 1. Cos minus pi is equal to 1, is equal to how much? 2 by pi into B max, 2 by pi into B max. Therefore, B average is equal to 2 by pi into B maximum. B average is equal to 2 by pi into B max. 2 by pi into B max. Okay? Yes. Now, flux density. Area under each pole. Let us calculate area. Is it clear? See, some student will raise a doubt. Sir, it is a sine wave. If you take B average, it will be 0. Don't take up to 2 pi. You have to take only half cycle. Half cycle. If you take full cycle, it is 0. No. If it is B average 0 means what is EMF? EMF also 0. Is it 0? No. In a coil, one side of the coil is cutting the north pole, other side is cutting the south pole. Net EMF is aiding polarities, aiding polarities. So you take only with respect to one conductor or one pole. Only one half cycles you take it. One half cycles, area under each pole. Each pole means what? You need to take north pole only or south pole only. Only one pole with respect to one pole. That's the reason I have taken 0 to pi. Base is pi. Okay. If you take 2 pi, you are going to get 0. No. Average value of flux is not 0. Next term. If this is pole, this is a pole. This is a pole, say. Correct? Yes. This is a pole, say. Similarly, this is another pole. This is another pole. Another pole. Rotor is like this. Is a rotor, no? Yes. The rotor. We are keeping 4 poles, say, for example, 4 poles we are keeping. But what is the area under each pole? We need to find. This is diameter of the diameter and this is length, L, length. Where D is the dia of rotor, L is the length of the core. Length of the core. Okay. Now, total area how much? Total area. Total area is pi d. Pi dl. Total surface area of the rotor. Total surface area. Surface area of the rotor. Total surface area of the rotor is equal to pi dl. Pi dl. Total surface area pi dl. But what is the area under each pole? Area under each pole is equal to pi dl by p. Correct? Yes. 4 pole aithe total surface area. Entire surface area, it is having diameter d, pi dl. Total surface area pi dl. But total surface area equally divided by each pole, na? Yes. This surface area is related to pole 1. This entire surface area is related to pole 1. Area under each pole is equal to pi dl by p. So with this, now I can average value of flux per pole. Phi average is equal to what? B average into area under each pole. Area under each pole. Therefore, B average is equal to 2 by pi. 2 by pi into B max. And area under pole, pi dl by p. Pi dl by p. Where d is the diameter, L is the length. D is the diameter, L is the length. That is equal to what? Pi will get cancelled. It is 2. Pi will get cancelled. Na? Pi will get cancelled. Finally, 2 into dl. 2 into B max. Or 2 dl by directly 2 dl by p into B max. B max. Therefore, phi average is equal to 2 dl by p into B max. B max. Two dl by B max. Similarly, this is phi. Instead of saying every time phi average, say phi only it is, phi only. Phi. And phi n, if you want to write phi n, say nth harmonic flux. 2 dl by np, n into p into Bn maximum. Bn maximum. This is for nth harmonic. Nth harmonic. Nth harmonic maximum flux density. Nth harmonic maximum flux density. But this n pi, why we are taking n into pi? N into p, that is equal to p suffix n. That's the reason we are taking. This for purpose, that purpose only. N into p we are writing na nth harmonic poles how many? N times that of fundamental. P suffix n is equal to np. Okay, have idea about these things. In the material, I have given problems based on this. You please do it. I don't want to do problems. Already we know how to calculate. This is only the key point. Based on this concept, you won't give flux directly. You will give diameter of the rotor, length of the rotor, B maximum. Then you need to calculate flux value. Then E is equal to known relation. Similarly, on this, another important type of question is objective questions. Let me give. Now, question is, if the linear dimensions linear dimension means what? Length and diameter. That is length and diameter. The linear dimensions of an alternator. Linear dimensions of an alternator is doubled. Then the generated EMF. Will increase. Then the generated EMF will be, say, then the generated EMF will be A bit. A bit 2 times B bit, 4 times C bit, 8 times D bit. Same. No change. No change. What is your answer? A bit 2 times, B bit 4 times, C bit 8 times, D bit no change. See, dear students, length are double, both are double. To flux. And assume flux density, other things are same. B max is same. B max, other things are assumed to be same. B max is same. EMF double with same B max. Same B max. Yeah, maximum flux density is same. Okay, we know that phi average is equal to what? 2 dl by P na solution. Phi is equal to 2 dl by P into B max. Okay, this is phi 1, say phi 1 is equal to phi 1 or case 1. I can write case 1. Case 1 is phi 1 is equal to 2 d1 L1 by P into B maximum. B maximum same. But case 2, second case, what happened? Phi 2 is equal to 2 d2 L2 by P into B max. B max is same. B max is same. B1 maximum, B2 maximum same. That is equal to 2 into, what is that? 2 D1, because dimensions are double. D2 is equal to 2 D1. L2 is equal to 2 L1. 2 D1 into 2 L1 by P into B max. So, if you take phi 2 by phi 1, how much? Phi 2 by phi 1 is equal to 4 times. Now just take it. Phi 2 by phi 1 is equal to 4. Therefore, phi 2 is equal to 4 times of phi 1. 4 times of phi1. Then what will be the induced EMF? Other things are same. Therefore, E2 also equal to 4 times of E1. 4 times of E1. So answer is B. Answer is B. Answer is B. Because E is equal to 4.44 kb. Since E is proportional to flux. E is proportional to flux. Next, if dimensions are double, but to maintain the same voltage, what should be the number of turns? The question is like this. Question is, if the linear dimensions are double, then to maintain the same voltage, maintain the same voltage, the number of turns, same voltage, the number of turns, will be how many times? A bit, 2 times B bit, 4 times C bit, 1/4 times D bit, 1/8 times, 1/8 times. Okay. You can say answer now directly. All dimensions are double. Now, to maintain the same voltage, I want voltage same, but dimensions are double, voltage same. Then number of turns has to be reduced. Yes, number of turns has to be reduced. See, E is equal to 4.44 kp kd phi f turns per phase. Turns. Easy. E is proportional to what? Flux into turns. Other things are same. Kp, kd is not mentioning anything. Vmax also will be same. Only dimensions. Phi into t. So, and we know that D2 is equal to how much? Flux phi 2. Earlier we found, na? Yes. Phi 2 is equal to 4 times of phi 1. As earlier. Same as earlier. Okay. Then E2. So therefore, E2 must be equal to E1. E2 must be equal means phi 2 into T2 must be equal to phi 1 into T1. But what is phi 2? Phi 2 is equal to 4 times of phi 1 and T2, that is equal to phi 1 into T1. Therefore, what is T2? T2 is equal to this will get cancelled, phi will get cancelled. T2 is equal to 1/4 into T1. 1/4 into T1. That is your answer. So what is the answer? Therefore, answer is C. Okay. The direct question. Now, after getting idea, only the students, these are said to be micro notes you are going to prepare. 2dl by p into p. Now you can remember directly, when all dimensions are double, flux is going to be 4 times increases. Flux 4 times. Then to keep the same voltage, what to do? Number of turns you can reduce 1/4 times. Number of turns can be reduced to 1/4 times. Like that. But keep in your mind what is happening flux. Similarly, if the linear dimensions are doubled, and linear dimensions are doubled, and the number of armature turns also double. Number of armature turns also doubled. Then the EMF will increase. By maybe 2 times, 4 times, C bit 6 times, D bit 8 times. What is your answer? Okay. Answer will be from this. We know already. Phi2 is equal to 4 into phi1. And T2 is equal to T into T1. So E is proportional to flux into T. Therefore, E will be increased by how many times? Therefore, E2 will be E2 is equal to 8 times of E1. 8 times of E1. And the flux is increased by 4 times, voltage increase. Number of turns also increased 2 times. 2 times. 4 into 2 times. How many times? 8 times, no? Yes, 8 times. 8 times. If only length of alternator, length is doubled, then EMF is A bit how many times? 2 times, B bit 4 times, C bit 6 times, T bit 8 times. Only length is doubled means what will be the flux? Flux is equal to 2dl by P into B max. Okay. This is phi1, say. Phi1 is equal to 2d1 L1 B1. But what is phi2? Phi2 is equal to 2d2 L2 by P into B max. What will happen? And that phi2 is equal to 2 into D2 is same. D2 is equal to D1. D2 is equal to D1. But L2 is equal to 2L1. This is you need to substitute. L2 is equal to 2L1 by P into B max. Therefore, phi2 is equal to how much? Phi2 is equal to okay, 2 into 2d1 L1 by P into B max is equal to how much? 2 times of phi1, na? 2 times of phi1. Therefore, EMF E2 is equal to 2 times of E1. Yeah, this much discussion also not required. Yes, students, are you getting? 2dl by P. Where diameter is double, EMF also double. Only length is double, EMF also double. If D and L both are double means 2 into 2, 4 times. If number of turns also double, 8 times. Correct? That's what. So this is about your questions. These are called what? Untapped areas. Untapped. Untapped. This is not only GATE or IAS examination, other examination are typical questions. These are called what? Typical questions. Okay, fine. Yeah, now the time is 9. So I told that 9 o'clock we are going to close. This topic is over. Today we will start with new topic. Today we are going to start with advantages of star connected armature winding. Advantages of star connected armature winding. Followed by rotating magnetic field. And then armature reaction. Okay. So up to now, whatever we have seen, it is mainly armature winding is a big topic. We have seen short pitch winding, full pitch winding. Okay. And all varieties of questions. Yeah, right. Okay. Now let me attempt your doubts. Yeah, tell me. Who is this? Okay. Sai Charan Reddy. I'm unmuting you people.
Good evening, sir.
Good evening.
Sir, I have a doubt that when there is the B wave in let's suppose for north 4-pole machine, when we are traveling from north to south, any 2-pole consecutive, then
Yes.
We are getting for the third harmonic, we are getting 3 cycles. Then that for 3 cycle, how that average value will be calculated? Because for 120 degree 1 cycle, that average value will be how calculated.
For which one? Which one?
Sir, that is B wave from phi average from the B wave.
Correct. B value, no?
That is flux average value from the B wave.
Tell me.
Means from north pole to south pole, any in the space when we are traveling, we will see that that is 3 cycles of B wave is occurring for third harmony.
Yes.
Then average value how will be calculated?
This is only the formula. Phi n is equal to 2dn by n into p B maximum.
But here, but that 3 cycles, north pole, south pole, north pole, south pole. But in a space we are traveling north to south in a for 180 degree electrical.
This is first of all diameter and length we have taken. Band and length does not depend on the harmonics, nothing. They are fixed.
Yes.
Okay.
Yes.
What is your observation? Poles only will change.
Yeah.
For example, under one pole there will be 3 harmonic poles will be there, na?
Yes.
That's the reason we are multiplying with n into p, and that will be Bn maximum also.
Yes.
Fundamental P means n into p. 3 p we will take wherever you start reference point. This is for one pole pitch we have done. Okay. For nth harmonic means it may be not necessary to take same point reference. For nth harmonic also, this is one pole means it will be equivalent to 3 poles.
Yeah.
Divided by 3 and B nth harmonic. B maximum is not equal to fundamental B max.
Okay.
Fundamental B max. This is fundamental say this is third harmonic B max is different.
Yes.
B max is different.
Okay.
Even though even if only for one pole 0 to how much angle it will be 60 degrees of fundamental you have to take the derivative.
Okay.
60 degrees you need to take.
Okay. 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 And sir, you are saying a point that B max is constant. Means for if we are means comparing.
Yeah. B maximum value is taken same.
How can we if a machine in a machine, how can we achieve that B max is constant? Means how we are exciting so that B maximum is constant.
B maximum Do you think this is dimensions are increased means V maximum also you are expecting increasing?
Actually, I have no idea about how the orientation.
I am designing my machine for the same flux density. Flux density V maximum same. When dimensions are increasing means flux increasing. We don't think when flux increases, V max increases. Maximum value of flux we are taking same. Your machine you can design to have the same V maximum. Flux per area, V maximum means flux per area.
Okay, this is right, but how means B maximum is means machine is we are dealing with same B maximum means what, sir, actually?
See, the pole width is increasing, na? This is pole. Okay. I will take another diagram. See, this pole if you take, and if you take this pole, diameters are increasing, diameter length is increasing. Okay.
Yes.
In both cases, which case flux will be more? Tell me. Dimensions are double.
Okay.
Second case, definitely flux will be more. Flux density may be same.
Yes, because there is.
Flux density may be same, but average value, space is increased here. Average value of flux. And that to
then we have to increase also number of turns in the.
When diameter length increases, what is going to happen? Reluctance is reduced. Reluctance of the pole reduced. Therefore, for the same given field current, I am also saying you may say, sir, field current increases. What will happen? I am not changing field current. Field current to be taken same only. Other things are assumed to be same. Then only your equation will be valid.
Okay.
Other things we need to take and same. In the questions he has given with constant Vmax.
Yes, sir.
That should be given.
Okay, okay, sir. Clear.
Right.
Thank you. Sir, another thing is, sir, for some batches actually DC machine and induction machine is not completed, means not started yet, sir, because of.
Okay,
sir. So you can take it 9:30 or 9:15.
Up to 9:15.
Because up to November, if a course will be completed, then it will be means after that I know that S will be take more classes. Means now it is 6 to 7 hours, then it will be around 10 hours sometimes after. So,
no problem. I am going to cover. Nothing to worry. 15 minutes extra I am taking. Say, so 15 minutes means if I take one class. So for example, instead of starting 5 o'clock, if I may start 3 o'clock, say, so that 3.5 hours can be covered. That is equivalent to how many? 15 minutes. It is equivalent to the 8 1 week. Instead of struggling every 1 week for 15 minutes, and one particular day I will take with one break in between. Extra hours I will take. Don't worry, I will manage.
You have said that for some batches already completed induction motor, I mean machine.
How it is related with the synchronous machines? You need other people need more time, that is going
because, okay.
That is going parallelly. The other faculty will start some induction machine. That will be go parallelly.
Okay.
You are having classes how long? From every day?
Sir, in the morning it will be from 6:30 to 10 o'clock. And in the evening it will be for 5:30 to 9:30.
Okay. After a few days they may start in between and one more session.
Because for November definitely the course is not going to complete actually. Yes.
Okay. They will.
Okay, sir. Okay. Thank you.
Okay. Right.
Thank you.
Next, Sai Charan. Who is there?
Hello, sir.
Hello.
Sir, in case of single layer winding, the conductors per slot and conductors per coil side will be same, na sir?
Huh?
For single layer winding,
Ah.
if we consider conductors per slot or conductors per coil side, then both will be same, na sir, in single layer.
Yes, exactly correct. Exactly correct.
Okay, if we assume that a coil has 6 turns, and if we assume 2 layer winding, then the conductors per slot will be 12, na sir?
Tell me, what is that?
If you assume that a coil has 6 turns,
Coil, 6 turn coil. 6 turn coil. Okay.
and the slots are double layer slot, double layer winding. We want double layer winding.
Double layer winding. Definitely you have 12 conductors per slot.
It will be compulsory 12 conductors per slot, sir.
Well, only will come. See, you draw the diagram like this. That's the reason I have spent. See.
Okay, sir. I understood the diagram, sir.
12 only will come.
Okay. In all
Why?
the 12 only, sir.
Oh, this is one slot. One slot. 6 turn coils, double layer. And each coil will have, or else you can draw this much diagram, that will be enough. Okay. Coil. You keep one coil side here, one coil side here, one coil side here, one coil side here. 6 turns means coil side, how many conductors will come? 6 will come. Each coil side will be 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. It will come 12 conductors.
Yes, sir. Yes, sir.
This is a 6 turn coil. Coil side only we are writing. Coil side we are drawing. Na? Yes, for one coil side. This is one coil. One coil. How many turns are there? 6 is there. 1, 2, 3, 4, 5, 6 is there. Okay. 6. How many conductors due to this one? Tell me. 6 conductors on this side.
6 conductors.
6 conductors, na? Yes.
Yes,
In this it is 6 conductors. 1, 2, 3, 4, 5, 6 conductors. This is 6 conductor we are showing from front view. Right? Similarly, 6 conductors this side also. 1, 2, 3, 4, 5, 6 conductors here. This side also 6 conductors. Due to one coil, 6 turn coil means this side 6 conductor, this side 6 conductor. That is forming 6 turns. Similarly, another coil if you keep double layer, na? 1, 2, 3, 4, 5, 6. Again it is coming. It is also black color also. 1, 2, 3, 4, 5, 6. Here also 1, 2, 3, 4, 5, 6. How many total conductors? 12 here, 12 conductors here. Right? Huh? Clear? Hello?
Good evening, sir.
This is clear. Earlier student was asked doubt. Okay. Right. Next.
Sir, in the first question of today's class, sir, the question was to find RMS value of induced voltage, no, sir. There we found phase voltage, even though it is RMS voltage. But
RMS phase. Yes,
generally, alternator, its voltage rating is in line voltage, no, sir. If that means
okay.
They did not specify like any line or phase voltage.
Okay.
In that case, any.
Oh, right. You are correct. But in the examination, you will mention phase voltage. Of course, I have calculated phase voltage. If you want line voltage, means √3 times. If it is a 3-phase star connection, √3 times.
Okay, sir.
If it is, of course, in that question it was not mentioned.
Yes,
In
sir.
examination, you won't say induced EMF is dash. In per phase value of induced EMF is dash or line voltage is dash. He will give.
Okay, sir.
Of course, there I have not given directly. I have calculated E phase. If you want line under √3 times, you can.
And one more, sir, small doubt. We are using short pitched winding, no, sir. there we are bringing the conductor which is placed in south pole to north pole. That means under north pole. Short pitching, if short pitched by some one or two coils,
Okay.
one or two slots.
Yeah.
If it was placed in south pole, the EMF was, even if you assume non uniform flux distribution, like chamfering of poles like that. Even though now we are bringing it into north pole, but the flux is again the same nature, no sir? How again harmonics are reducing, sir? A small confusion. By equation wise it is okay, sir, but just for understanding it is not.
Which one your doubt is with short pitch or distributed wave?
Short pitch, sir.
Short pitch means this is, yeah, this is one coil, correct?
Yes, sir.
Your doubt is when short pitch means, of course, average value of flux cuts by the conductor over a period 180 degrees. A conductor is rotated, say, or conductor is stationary, a pole is completely rotated, it will cut the total sinusoidal flux distribution. Okay, south pole also will cut an average within rotation. Do you want to show with the equation? Waveform?
Okay, sir, but here
You want waveform?
my doubt is like this, అంటే ఇప్పుడు మనం సౌత్ పోల్ పెట్టినప్పుడు సేమ్ సైనసాయిడల్ నేచర్ కదా సార్, అంటే అది నెగిటివ్ డైరెక్షన్ ఉన్నా కూడా సేమ్ నేచర్, ఫ్లక్స్ మెల్లగా ఇంక్రీజ్ అవ్వకుండా సాచురేషన్ పాయింట్ వరకు వెళ్తుంది, మిడిల్ పోర్షన్ వరకు. నార్త్ పోల్ లో పెట్టినా కూడా అదే సైనసాయిడల్ నేచరే కదా సార్?
నార్త్ పోల్ కూడా అదే ఫ్లాట్, ఏమనేది ఫ్లాట్ టాప్ వేవ్ వస్తుంది అంతేనా?
అదే సార్.
రెండిట్లో ఈ టైప్ ఆఫ్ వేవ్ ఫామ్ ఉంటుంది, ఇది నువ్వు చెప్పేది అంతేనా?
ఎస్ సార్, ఎస్ సార్.
అవును, ఈ సౌత్ పోల్ లో కూడా ఇలాగే ఉంటుంది. ఇప్పుడు కండక్టర్ ఇక్కడ పెడతా అంటాం అంతేనా?
ఎస్ సార్.
ఓకే, ఇప్పుడు ఇది కూడా రెండు అలా అవే ఆ ఫ్లక్స్ నే కట్ చేస్తుంది అంటున్నాం అంతే కదా?
ఎస్ సార్.
ఈ రెండు రొటేట్ అయినా కానీ టోటల్ లో వచ్చే కాయిల్లో వచ్చే ఫ్లక్స్ డిస్ట్రిబ్యూషన్ అనేది ఫ్లాట్ టాప్ కాబట్టి కాయిల్లో ఫ్లాట్ టాప్ వస్తుంది.
ఎస్ సార్.
ఈ వేవ్ ఫామ్ తో కాకుండా నేను ఒక ఫిఫ్త్ హార్మోనిక్ వేవ్ ఫామ్ వేసి చూపిస్తాను.
ఓకే సార్. ఎస్ సార్.
షార్ట్ పిచ్ వైండింగ్ యూ కాంట్ డూ ఎనీథింగ్, ఫ్లక్స్ వేవ్ ఫామ్ యూ కెనాట్ ఇంప్రూవ్.
ఎస్ సార్.
ఏమవుతుందంటే ఇక్కడ చూపిస్తాను చూడు, షార్ట్ పిచ్ వైండింగ్. Right. See, this is the fundamental, correct?
Yes, sir.
Now, a flat top only you can draw with the, this is fifth, fundamental. But the nth harmonic, 5 harmonics will be there now. Fifth harmonic.
Yes, sir. 5 cycles.
5 half cycles. 1, 2, 3, 4, 5 half cycles. 1, 2, 3, 4. This is a fifth harmonic. This is a fundamental fifth. These two together will form a flat top. If you add third harmonic, say అది flat అవుతుంది. A flat only we are divided into sinusoidal functions.
Yes, sir.
Divided sinus, a flat top wave divided sinusoidal. ఈ రెండింటిని యాడ్ చేస్తే మీకు నాన్ సైనసాయిడల్ వస్తుంది.
Okay.
If you keep conductor here, if I am keeping a conductor here and another one is here, full pitch అనుకోండి.
Yes, sir.
I am keeping full pitch coil. Full pitch coil. Fundamental, what about fundamental? Fundamental is cutting north pole flux in south pole flux.
Yes,
So
sir.
fundamental I can take this
Cross.
E1 cross is E1 dot. Okay, E1 cross E1 dot. Good. What about fifth harmonic? Fifth harmonic also
Even it is cross.
cross E5 cross and here E5 dot.
Dot.
Aiding, na?
Yes, sir. Aiding.
Totally aiding. harmonic is totally, both are aiding. Fundamental also aiding, fifth harmonic also aiding.
Aiding.
Is not eliminated. What is the angle? This is coil span, full pitch. I have taken
180 degrees.
180 degrees full pitch. For full pitch, fundamental is existing 100%. Fifth also 100%. Okay. I want to eliminate now. To eliminate, what I want to do is, instead of keeping my conductor here, one side I am keeping here, one side. Instead of keeping here, I will keep this conductor here. If I keep conductor here,
Now it experiences north pole flux again. So it is opposing the fifth harmonic flux of positive
going to be like this, E5.
Yes, sir.
E5 in this coil. Then both will get cancelled. What is this? This angle is alpha, I am saying.
Yes, sir.
Calculate how much alpha. See each pole. See, this is 180, no? This total is 180. From here to here, this is total how much? 180 degrees from 1/2 cycle, fundamental angle. What is this angle each?
1, 2, 3, 4, 5.
36.
36.
This also 36. Each half cycle 36. Now tell me, how much angle this is? 80. Half
Yes,
cycle.
sir. Yes, sir.
80. Total length 36. So with 36, if with alpha is equal to 36, fifth harmonic 100% eliminated.
Yes, sir. Okay.
Fifth harmonic is eliminated. That is what? Alpha is equal to how much? 180 by n. Alpha is equal to 36. Eliminated.
Okay, sir. Okay.
Okay. Because flat top means it is consisting of harmonics, na?
Yes, sir. Yes, sir.
You can analyze. A flat top can be analyzed with again sinusoidal functions.
Okay, sir. Clear, sir.
Very good.
Thank you, sir.
Okay. Next. Hello. Yeah. Who is there?
Hello,
Hello,
sir.
sir.
Tell me.
Sir, is there any relation between Bmax and Bn max?
What is the doubt?
Yes, sir. Like the maximum value of harmonic maximum flux experienced and the fundamental maximum flux experienced. Is there any relation between both, or will that be given in the question as data?
Yes, yes. You can take phi 1 by phi n by phi 1. We'll also get that relation. What is the relation is there? You know, phi n. You know, phi n is equal to what? 2dn. 2dl by n into p into b max. Pn max, na?
Yes, sir.
What is phi 1? Divided by phi 1 you take. Phi 1. Phi 1 is equal to what?
No, sir. Actually, flux density Bn max and B max relation.
That also, and you want to write in terms of phi n by phi n. This is only now. For this, 2dl by p into b1 maximum. Okay.
Okay, sir. Like my doubt was like we have B1 maximum, B2 maximum, etc. So does it have any relation with B max, the fundamental maximum value?
Not like that. You are expecting bn maximum is equal to 1 by n into b1.
Some relation is there, or we will get that as in the question itself as data.
You cannot get just like that.
Okay, sir. Okay, sir.
No relation.
Sir, then one more thing. Then in yesterday's class, we reached a conclusion that as the number of phases increases, the KVA rating also increases, right?
Yes.
Sir, then like why did we not go for more than 3 phases? Like, is there some reason for?
The 3-phase system already existing, number one. Second one, if you generate 6 phase generation level, fine, but transmission problems will come into picture.
Okay.
On transmission level, 6 conductors to keep space also you need to maintain.
Yes, sir. Yeah, correct.
phase also you need to maintain. How much cross transmission is going to be? Length of the tower has to increase. Okay. Length of the tower has to be increased. 6 conductors placing on that. That is going to be difficult. And best thing is 3-phase 4-wire system is there, na 3-phase 4-wire.
Yes, sir.
Neutral also will be provided. But what is the current in the neutral? No current in the neutral.
Current. Yeah.
So is there any copper losses in the neutral? No copper losses in the neutral. So the neutral wire may be thousands of kilometers, hundreds of kilometers, there will be no power loss. 3-phase 4-wire is the best thing.
Okay, sir. Sir, then one more thing, that lap winding, wave winding, will we discuss it in the future class or?
No, it will be our alternator distributed winding. It is lap only.
Lap winding, yes, sir. Wave winding.
No, that all they are related to DC machines.
Okay, sir. Okay, sir. Thank you,
If
sir.
you don't think number of parallel pass is equal to number of poles, not like that. We are not dividing our winding into parallel pass. Okay.
Okay, sir.
They are R phase windings are connected in series, Y phase. They are only 120 degrees phase difference.
Phase separate. Okay. Okay, sir. Thank you, sir.
Good evening, sir.
Hello. Tell me.
So, actually, the double layer winding you explained. So, in that, how you have kept the second phase of winding? Can you explain? I'm finding it a little difficult to visualize.
This diagram, no?
R4, R5, R6 you have placed, no? That one.
R4, R4 means from B1 to, you need to take B1 to 120, you keep where it will come. This is B1. RYB, again R will come after B, R will come.
Okay, so from B1,
RYB will come. So R1, Y1, B1 is over. From B1 to next coil, where to keep? From here, 13 to, count the angle, 13 to 20, 40, 60.
Okay. Sir, one more.
In that already top layers are filled up, then I can take bottom layer. Bottom layer number already R1, R3 is there, that's the reason I am keeping R4. 120 degrees, I mean, from here to here, 120.
Sir, in the section where you explained even harmonics do not exist, the fundamental waveform you formed and the coil direction, EMF direction which you have taken under North Pole cross. Can you explain how you have applied that right hand rule?
Where?
Under North Pole cross flux is there. That direction. How we get?
Okay. Normally, for example, see.
You have drawn also.
This one.
Yes, so you have explained. Yes, sir, this even cross.
For rotation, that I am taking just blindly. But when many times we have seen for many times we have seen for North Pole and North Pole. What is that? North Pole, it is cross.
So we are assuming North Pole flux as positive. That is assumption.
Assumption only. Or when pole is moving in clockwise or conductor is moving, rotating in clockwise, that is going to be cross. Rotation is clockwise. Cross you will get.
How the coil is kept physically, sir? Can you?
Kyle?
How the coil is kept? Can you explain with the hand or something? I am not getting this. How the coil is placed?
Okay. This is North Pole. North Pole.
Yes.
Okay. On this, I am keeping one conductor. I am keeping one conductor here. Fine. North Pole. But where pole
direction is
rotating in clockwise. Or you can take any one clockwise.
We have assumed clockwise is positive.
Which one?
You are telling that in clockwise direction we are taking positive.
Yeah. If rotor is rotating clockwise, pole is rotating clockwise, this is the flux direction.
Okay.
This is the flux. Here. Now apply your thumb rule. When pole is moving, conductor assumed to be rotating in
Rotating anti-clock
anti-clockwise.
because stationary.
Then apply your right hand rule. Entry.
Okay.
Flux here.
Inside. Okay, got it, sir.
Like that.
Okay.
So blindly I am taking every time cross. Even if you your analysis can take dot also, same things will be same. Dot is coming.
So it's just an assumption that we are when we are moving in clockwise direction, then we are taking positive. It's assumption.
If you take north pole crosses, south pole you need to assume dot.
Okay.
Opposite you need to assume. Analysis will be same.
Okay. Yes, sir. Thank you, sir.
Fine.
Good evening, sir.
Hello. Yeah, tell me.
Sir, we have seen that in 60-degree phase period, the third harmonics in the line voltage is not there, na sir?
Yes.
But it's present in the phase winding. So
Yes.
if we take in the entire system, means we have taken the three-phase line supply, and at any place in the system, we take single phase supply from it. Then there will be third harmonics present in it.
Yes.
So
It will
how,
be present.
yeah, sir. Then how are you
Per
going?
phase voltage, if you take, you will present. But where you will take, you will take per phase value for what purpose? Lighting purpose.
I have some suppose transmitted it with using line and taken supply single phase supply from it after some time using after transformer. There will be third harmonic there, sir.
Yes. But that third harmonic, sir, that is our topic next. Advantage of star connection.
Yes, sir.
See, this is star connection. When load is your RL load. Okay.
Okay, sir.
RL star connected load. Fine. Here, there will be no triplet harmonics that will circulate. This is coming to here.
Okay.
Coming to here like this. Okay.
Yes, sir.
In the lines it won't exist, but the phases, the circulating currents will be through the phases.
Yes, sir.
It will take a path like this. Third harmonic will take a path like this.
Right.
Through the ground.
Okay, so it will be eliminated through the ground, sir.
It will be there, exist in the ground. If you star connected alternator, load is also star connected, it will take a path. But what we will do,
Yes, sir.
that will be reduced by connecting a large resistance in the neutral or reactance.
Okay, sir. Okay.
Their currents will reduce.
Yes, sir. Right.
Their currents will reduce. And if you take only one phase, one neutral for your single phase, that will exist definitely.
Third harmonic.
Lighting purpose, for example, where you can take single phase lighting purpose. For lighting purpose, if third harmonic is there any problem for you? No problem. Still you will get more light.
Yes, sir. Okay.
Generally loads are three-phase loads.
Yes.
So we will connect across the lines. On that basis, we will go in.
Right. Okay, sir. Understood.
Okay.
Thank you.
Yes. Hello? Anyone is there?
Hello, sir.
Tell me.
Sir, not a doubt, just a clarification.
Right.
Sir, in the class notes uploaded for yesterday's and day before yesterday's class, sir, I felt like 1 or 2 pages are missing in between.
Yesterday I have, there is no missing. Of course, day before, I think fourth day, 1 or 2 slides may be missing. When it is doing that was deleted actually. Only that is nothing but there. Armature winding. Winding is there, na armature winding, concentrated, distributed.
Yes,
Under that full pitched and short pitched. Okay.
Ah.
The short pitch, fractional start and integral start winding. That slide is missing. That's
sir, and like the last portion, that advantages of short pitch winding, I think that was also not there in the
all. That also is not there. Huh?
sir.
Okay. Yeah. You are also having this booklet.
Which, sir?
This one booklet is there with you.
Yes, sir.
That if any 1 or 2 slides are missing, you please check it. From here onwards, I will take care not to miss. But
Okay.
when we are editing, there may be one slide is going, say it cannot be again recovered. Okay.
Okay.
Yeah.
Okay.
From here onwards, so you will get all the slides. Don't worry.
Thank you, sir.
Hello, sir.
Hello.
Hello, sir.
Tell me, ma. Hello.
Hello, sir.
Yeah. Tell me.
Sir, full pitch winding means exactly one coil, no, sir, 180 degree.
180 degrees. Correct.
Now short pitch coil is greater than 180 degree. What is
No, short
what-
pitch is less than 180. Over pitch అయితే more than 180.
long pitch winding means, sir?
More than 180 degrees.
Like RYB combination, sir, total.
No. What is your doubt exactly?
Long pitch winding, sir.
Long pitch winding అంటే R phase only. R1 is kept here. R1 dash can be kept in more than 180.
More than 180 degrees.
Yes.
Sir, one more doubt, sir. Sir, in phasor diagram, sir, phasor diagram లో సార్ R ని రిఫరెన్స్ గా తీసుకుంటే సార్ లీడ్ లాగ్ ఒకసారి ఎక్స్ప్లెయిన్ చేయరా సార్?
R phase ని
రిఫరెన్స్ గా తీసుకోవాలి సార్.
R phase ER ఇది EY ఇది EB. ఈ ఫేజార్స్ ఎట్లా అనేది తీసుకోవాలి. ఫస్ట్ ఫేజార్స్ ఏ డైరెక్షన్ లో అనుకుంటున్నారు? కౌంటర్ క్లాక్ వైజ్. కౌంటర్ క్లాక్ వైజ్.
ఓకే సార్.
ER0 తీసుకుంటే EY మీకు ఎప్పుడు వస్తుంది? లాగ్ లో ఉంది. లాగింగ్ అంటే వెనకాల ఉంది అనమాట.
ఓకే సార్.
ఇప్పుడు ఫర్ ఎగ్జాంపుల్ ఒక మనిషి ఇక్కడ ఉన్నాడు, ER అంటాడు, ఇక్కడ ఉన్నాడు అనుకోండి. ఈ ER ఫేజ్ ఇది.
ఓకే సార్.
అండ్ దిస్ ఫెలో ఈజ్ Y phase అనమాట.
yes sir.
All they are going in the same direction. They are going in the same direction. Okay. It will also going in the same direction. Who is lagging? Tell me. He is also going like this. He is also going. Who is lagging?
Why no sir?
Why lagging?
In case Y is reference, sir.
Y is Y reference అయితే అప్పుడు ఏమవుతుంది? మీకు Y0 తీసుకుంటే EY if you take if ER0, let me write. ER0 means EY is minus 120, EY minus 120, EB minus 240. Okay na? Right. ఇప్పుడు ER0 EY minus 120, EB minus 240. Okay. This is phase sequence ఏంది? ఇది RYB అవుతుంది. ఇప్పుడు EY రెఫరెన్స్ తీసుకో. EY0 అనుకోండి. EY0 తీసుకుంటే ఈ రొటేషన్ డైరెక్షన్ లో ఏది లాగ్ అవుతుంది? EY కి EB minus 120 అవుతుంది. అంతే కదా? ఈ రెండింటికి మీకు ఈ B లాగ్ అవుతుంది. ఎంత యాంగిల్ తో? 120. ఈ R ఎంత? మైనస్ 240. దీని ఫేజ్ సీక్వెన్స్ ఏంది? YBR. YBR. కానీ ఈ YBR ని మళ్ళీ ఎలా రాసుకోవచ్చు మీరు? YBR ని B నుంచి స్టార్ట్ పెట్టారు. వెరీ గుడ్. BRY. R నుంచి స్టార్ట్ చేస్తే ఏమవుతుంది?
RYB. అంటే నా డౌట్ అది కాదు సార్. లీడ్ ల్యాగ్ అనేది లిటిల్ బిట్ కన్ఫ్యూజ్ సార్.
లీడ్ ల్యాగ్ అంటే ఏం లేదమ్మా. లీడ్ ల్యాగ్ అంటే నేను ఇందాక అదే వేశాను చూడు, ముగ్గురు నేస్తాను నేను. 3 members ఒక సర్కిల్లో వెళ్తున్నారు అనుకోండి. చెప్పింది ఇదే. ఇక్కడ చూడు. ఇప్పుడు లీడ్ ల్యాగ్ అంటే ఫేజార్స్ ఏ డైరెక్షన్ రొటేట్ అవుతుంది? కౌంటర్ క్లాక్ వైజ్ రొటేట్ అవుతున్నాయి. అవునా? ఈ ముగ్గురు ఉన్నారు. దిస్ ఫెలో ఈజ్ మూవింగ్ ఇన్ దిస్ డైరెక్షన్. ఇలా వెళ్తున్నాడు కౌంటర్ క్లాక్ వైజ్.
ఓకే సార్.
ఓకే. అండ్ దిస్ ఫెలో ఆల్సో ఈజ్ మూవింగ్ ఇన్ దిస్ డైరెక్షన్. ఇలా వెళ్తున్నాడు. ఈ ఇద్దరిలో ఎవరు లాగ్ అవుతుంది చెప్పండి? ఎవరు వస్తున్నారు? ఫస్ట్ ఫేజ్ అనేటోడు వెళ్తున్నాడు. తర్వాత ఎవరు వెళ్తున్నారు? Y phase. అట్లా. లేకపోతే ఇంకా మీరు డౌట్ ఇది కాకపోయినా ఒక రెఫరెన్స్ దగ్గర కూర్చోండి మీరు. ఇప్పుడు దిస్ ఫెలో ఈస్ దేర్, ఒక రెఫరెన్స్ పర్సన్ ఉన్నాడు అనుకోండి. ఓకే, ఈ స్టాండింగ్ హియర్. ఫస్ట్ ఏ వెక్టార్ క్రాస్ అవుతుంది? ఆర్ ఫేజ్ వెక్టార్ క్రాస్ అవుతుంది, ఆ పర్సన్ నుంచి వెళ్తుంది. దాని తర్వాత ఏది వెళ్తుంది? వై వెళ్తుంది. దాని తర్వాత ఏది వెళ్తుంది? అదే ఫేజ్ సీక్వెన్స్.
నౌ హియర్ బి అనేది లీడ్ లో ఉంటుందా సార్? ఆర్ కి బి అనేది లీడ్ లో ఉంటుందా సార్?
లీడింగ్ ఉంటుంది. ఎగ్జాక్ట్లీ. మీరు ఇప్పుడు దానికి ఈఆర్ 0 తీసుకొని ఈబి ప్లస్ 120 తీసుకున్న కరెక్టే. ప్లస్ 120 ఈజ్ ఈక్వల్ టు ఈబి మైనస్ 240 కరెక్టే. ఇక్కడ నుంచి చూస్తే ఇది లీడ్ అవుతుంది అమ్మా, కానీ ఇక్కడ నుంచి చూస్తే ఏమవుతుంది చెప్పండి? లాగ్ అవుతుంది. ఇదేమో 120 degrees లీడింగ్, ఇక్కడ నుంచి చూస్తే 240 degrees లాగింగ్. రెండు కరెక్టే. ఫేజ్ సీక్వెన్స్ మార్క్ ఏం రాదు. ప్లస్ 120 బదులు మైనస్ 240 రాసుకుంటే సరిపోతుంది. అన్ని మైనస్ లో రాసుకుంటే క్లియర్ ఉంటుంది. ఓకేనా?
ఓకే సార్. ఓకే.
ఐఎమ్ క్లోజింగ్ మై సెషన్. ఓకే.